Thanks everybody for joining us. We're really excited to have you with us. So good morning, good afternoon, and good evening, wherever you are in the world. Welcome everyone to Collate Summit 2026, Data and AI in Production. We're really super happy to have you here with us today. My name is Steve Woolidge. I'm the head of marketing here at Collate, and I'd like to introduce James Nguyen, who's not on stage at the moment, but he'll be leading the product track number 2, or the breakout track number 2, when we get into the breakout tracks after the keynotes. He's our product marketing leader here at Collate and has really put a lot of time into this event. So happy to have him with us today. Now, before we get started, a few housekeeping items. Please make sure you're on the latest version of Chrome or Edge. We are on the Ring Central platform. There are some quirks. If you aren't using that latest browser, that'll have the best experience, but we do have technical folks standing by if you have any questions. Please update your profile, join in the public and session chats. I see the session chat lighting up. We also have a Q&A there. We have a full team standing by, including folks from our engineering team, to answer any technical questions you have about the product or anything that you see during the event today. And again, please use that Q&A function. We don't have a ton of time in between sessions today. We're action-packed. We've got a lot of customers and community members joining us live, so we want to preserve that time as much as we can, but we will try to pick up questions where we have some slots. And so for those of you who need it, which sometimes I like to have it, we also have closed captioning and subtitles, which I'm told is on the bottom right-hand side of your viewing experience. And finally, last but not least, let's be respectful and courteous today. We have a lot of people in from all over the world sharing a lot of different ideas, and that's what it's all about today. So thanks again for joining us. I'd like to take a quick look at setting the context for what we're doing today. No pun intended, but there'll be a lot of conversation around context. And so here's that framing. We all talk a lot about AI, and I've been in this industry for 20 some years. It's never been more exciting to me to see what we can do with AI and what we've been able to do in terms of AI for code. But tools like Claude Code and Codex from OpenAI have been really great for developers, but they haven't been as fruitful in structured data. And so bringing AI for data using LLM tools is part of what we'll talk about today. And we'll learn from teams that are already doing this, folks like OpenAI, who will join us later in the keynotes, and others who will talk about what they're learning, and that the magic isn't in a bigger model and who has the latest benchmarks, whether it's 4.8 or 5.5 or what's it called, Fable now. Versus Mythos. It's really the context layer underneath it. It's that semantics, the ontologies, the structure of the data, the memory that we can collect, the organizational knowledge that then let people and AI agents get answers from the data that they can actually trust. And that matters incredibly when you start thinking about letting AI agents and automation start to make decisions on their own, where they don't know when to phone a friend or get some context from somebody. They're just going to make assumptions and take an action. And sometimes hallucinate very confidently. So it's important to get that layer in place. And so today we'll have 3 threads. First is the building of that context layer, that trusted foundation. Second is how do we put AI agents to work on top of that, which Harsha Chintalapani, our CTO, will dig into and talk about Collate 2.0, which we just announced this morning via a press release. So we'll be sharing some incredible product updates with you all today. And the third section of this, or the thread, will be governing all of that in an AI-first world where the number one thing consuming your data will probably wind up being an agent and not just a person. I heard a stat this week that there's more agents now that are crawling web pages and looking at HTML than there are humans at the moment. And you could expect that probably within your organizations at some point as well. And so you'll see these 3 threads woven across 2 breakout tracks. We'll have a governance panel that I'll have the honor of hosting in a little bit, and we'll get an update from the OpenMetadata community. So let's double click a little bit into the agenda and what we'll see today. And so we have 4 action-packed hours today. We do have a short break that's built in. We'll be starting off soon with an opening keynote from Suresh Srinivas, our co-founder and CEO, describing why AI for data needs a new foundation. After that, Bonnie Xu from OpenAI will join us to talk about her own internal data agent that she and their team made on top of that foundation of trust. Next, we'll turn things over to Harsha, our co-founder and CTO, for that deep dive on Collate 2.0 that I mentioned, where he'll be showing and talking about what it means for putting data to work using AI. And then I'm really excited. We have some customer lightning talks. We've got 2 great speakers. One is Angelita from Scout 24, and Amy Forrest from Yelp. They'll both be talking about context and how they're using that within their organizations to drive AI-driven analytics, as well as better search within their organizations. After that, we'll move into a speaking panel where we'll have Angelita join right back in, and then we'll be joined by Lucas Patsky from Airbus and Dan Kostecki from Ambry Genetics, where we'll be talking about governance in an AI-first world and what assumptions need to change and how we think through delivering data as a product and governing that in an AI-first world. And from there, we'll break out into 2 separate tracks, and I'll talk that through in a minute. And so you'll have a choice to stay here in track 1 or head over into track 2, and I'll give you some detail on that. After that, we'll all come back together for the update from the Open Metadata community with Sean Gordon. He has a special guest that he'll be bringing on. And then we'll break out we'll stay together and do our community and customer awards. So now if I could, let's go ahead and double click into those breakout tracks. So track 1 is all around that thread I talked about of context and governance. Each of these tracks will have engineering leads from Collate walking through live product demos. In that first track, we'll have 2 team members that will talk about how to build a context layer using AI to then give AI better intelligence as well as the people. Then we'll turn things over to Dan Kostecki with Ambry Genetics to dig into how he's delivering clinical data products and governing that at scale. And then Jeppe Johansen from Unity will walk through compliance review, excuse me, and incident triage using Collate's MCP. So if you want to attend that, you just stay in this track, all good to go. Track 2, when I give you, don't do this now, but you'll be able to go and click on stages in track 2, and you can attend these sessions and you can swap as we go. But in track 2, we'll be focusing on data and AI in production, what it means to deploy this capability on top of that context layer that we talked about. So we'll have Pere Miguel Bruel, one of our founding engineers, and our CRO, Nick Doyle, who will walk through a real life business use case, showing off some of the new capabilities within the products that allow them to go from simple questions in Slack or in a chat interface to creating a dashboard to get insights and then driving automation on an ongoing basis within the business. Harsha Chintalapani will also drop in to join the session and do a double click into some exciting new product news that we have today that didn't even make it into the press release, or some really exciting new stuff that he'll have to show. And then in that track 2, excuse me, we have 2 gentlemen from the Asia Pacific region. One is Mukhtafi Ahmed from Rakuten, who will describe their journey with Open Metadata, moving from a metadata catalog to using an agentic context layer for their AI initiatives. And then Serene from UnionBank of the Philippines will close things out in track 2 by sharing their story on scaling data products and governance at their digital-first bank. So quite an action-packed agenda. Now, before we dive in and have Suresh join us on stage, we do have 5 polls today. We'd love to get just a pulse from the audience on where you are in your journey. So if you click on the right-hand side, you should see a place where you can open up the poll. And if we can push this live, the first poll is, where is your organization in your agentic AI journey today? Option A, you might still be exploring things. Maybe you just downloaded Codex, or you're playing with some stuff, trying to connect it to your data. Option B is you've got a few agents that you're pushing into production. You've got some use cases that have been defined with the business, but it's mostly internal and maybe single purpose agents. Versus option C, where you're scaling things. Maybe you've got multiple AI agents in production, starting to get some traction. And AI first would mean that you've got AI agents embedded in all of your, or many of your, operational processes. So if you can, just please go ahead and click into that. And I would love to share the results. I'm not seeing where I might be able to do that. So if we can't share the results here, we will definitely be bringing that back to everybody with a research report afterwards. So I don't know if the production team is able to share this or not. I don't see the option to share it on my side, but all good. So hopefully you've been able to respond to those polls. All right. So let's go ahead and get things started. Today, we're going to kick things off with a conversation that's especially timely for all of us that are in this fast-moving data and now AI analytics space. And I'm thrilled to bring onto the stage Suresh Srinivas, our CEO and co-founder here at Collate, also one of the core authors on the OpenMetadata project. Welcome, Suresh. For those of you who don't know, he's a longtime data leader. Prior to co-founding Collate and the OpenMetadata project, Suresh was the chief data architect at Uber and former co-founder of Hortonworks. He'll be sharing his vision for why AI for data needs a new foundation. Suresh, take it away and welcome. Great to have you.
Thank you, Steve. Hello, everyone. Welcome to Collate Summit. I'm Suresh, CEO and co-founder of Collate. AI will completely transform how we do data today. But today's data architecture is built for people and not for AI. The next 20 minutes are about one question. What will it take to enable AI for data? AI for coding has transformed how software development is being done. A large part of code in organizations today are being built using AI, and vibe coding has become a thing. But how about AI for data? Why does AI for coding work, and why doesn't it work for data? AI for coding works because software has a strong and mature foundation for AI. All source code is in one place in source code repositories for AI to discover it. Dependency graphs between components are clear and explicit. There's Git history that includes versioning and issues captured, discussions, and every decisions that are made right around software development. There are also product requirements, design documents, and spec files. There are tests and CI/CD to validate the code being generated from AI. And most importantly, code reviews keep humans in the loop. Codex, Claude, Cursor, they all walked into this infrastructure that engineers have spent years building. AI for coding didn't get smart by accident. It got smart because the context layer was already there. Now, let's look at the data side. Let's look at the data side. Same parallel, but different reality. Where does data live? It's scattered across thousands of tables, warehouses, lakes, and spreadsheets. There is no single place for AI to discover the data. What does the data mean? There are 4 definitions of revenue, customers across DBT, BI tools, and the warehouses. There is no semantic layer to understand the data for AI. There is no history of decisions, right? They live in Slack threads and as tribal knowledge in someone's head. There are no quality checks. They are non-existent or inconsistent. Can AI trust the data? With such data, can AI produce right results? Right? So each box you see in red is what AI is missing with data. Today's data agents face conflicting definitions, stale grounding, there's no canonical context, and poor quality data. Deploying intelligence without the context leads to guessing at scale. The LLMs are making rapid progress in capabilities, but the enterprise data accuracy hasn't moved. That's because of the context gap. Now, the yellow band on this chart is the gap between what the model can do and what the model actually delivers on your data. Look at what happens when you measure the accuracy. Right? Spider 1.0, the academic benchmark with 10 clean tables, the frontier models score above 90% in accuracy. Now, run the same models on Spider 2.0 with real enterprise schemas. GPT 4.0 drops to 10.1% in accuracy. Sonnet 4.5, on the same task, 10.8% in accuracy. Same LLMs, same intelligence, 80-point accuracy collapse. This is the reason why AI demos for data look great, but you use in production, the accuracy falls apart. Does deploying a more powerful model fix this? The answer is no. What needs to change is fixing the context gap. Here is the same problem in one picture. Right? Today, context, semantics, and memory are fragmented everywhere. Context is scattered across catalogs, warehouses, lineage tools, dashboards, and comments, and things like that. Right? Now, semantics live separately in BI tools, DBT projects, analytics apps, wikis, and spreadsheets. Memory, if tracked at all, is isolated per agent. There are so many agents, but none of them learn from each other. If you want to enable AI for data, this must change. What enterprise need is one brain with complete and connected context, one shared meaning for all, both people and AI, one shared continuously learning memory, all integrated together. So the question I ask each of you is, which side are you building towards? We have been making the argument for this context for months. The world is finally catching up to it now. Gartner has now made this argument independently that semantics and context are the brain of AI. Without context, AI agents hallucinate, introduce bias, produce unreliable results. You've all seen this. Traditional technical metadata no longer suffices because it lacks business meaning, and AI doesn't understand your business. And Gartner's explicit advice: establish a context layer as core infrastructure and as clear foundation. Gartner predicts by 2027, organizations that prioritize context layer increase agentic AI accuracy up to 80% and cut the cost by 60%. That open context layer is exactly what we have built in OpenMetadata. Now, there are three primitives in open context layer to close this gap. The first is context. It connects all your metadata into a single, unified, open knowledge graph. Semantics adds business meaning to your data. Memory captures every decision, feedback, and preference. Apply it in the next one. The point of breaking it into three primitives is that each one is independently buildable. They're independently testable, and they are connected. These three primitives are what AI for coding has by default. This is what a context layer for data needs. Now, let's deep dive into these three primitives because there's a lot of confusion about what context means, what semantics means, and how they need to come together. The first primitive is data context. This context describes what data you have to AI, right? Now, Open Metadata has been building this context for a long time in the open source with the help of community. Open Metadata unifies 6 dimensions of metadata into a single unified graph. Technical metadata, quality metadata, lineage, business metadata, even operational metadata with observability signals. And it also even includes social metadata, right? The upwards and who is following the data and what conversations are happening about it. There are over 130 plus connectors that connects all your data real estate, starting from your OLTP databases, ETL tools, ingestion tools, data lakes, data warehouses, dashboard systems, your machine learning systems, you name it, right? These connectors collect all the metadata from all these different sources and connect them into a single unified metadata graph. The result is a single system of record that answers everything about data to AI, right? What data exists, who owns it, is the data trusted, is it fresh, what depends on this data, right? Same unified graph, same consistent answers for both human and for AI. Now, context tells AI what data exists. Semantic tells AI what it means. Now, today, right, for the data foundation that we have built for people, the gap of meaning is filled by domain experts, right? When you're using data, you can, find an expert. If you can find at all, you find an expert who understands the business, and then you can ask him what certain concepts mean. You can understand the nuances of this context. But AI doesn't have this luxury. It doesn't stop to ask questions. It makes its own assumption or guess the meaning to arrive at the wrong answer. And without semantics, all AI sees is column names like customer underscore ID, account underscore ID, buyer underscore key. 3 columns and no idea which one is the actual customer. Open metadata makes business concepts, glossaries, metrics, classifications, domains, and policies all first-class objects in the same semantic graph to enable to, in fact, make business meaning explicit, right, for data to AI. This is how you teach AI about your business. Otherwise, it is flying blind. The semantic layer in open metadata is built with open standards like RDF and OWL, the web ontology language, as a single knowledge graph. Now, here is what business meaning looks like using formal ontology, right? The old way of defining that in today's world is, by using business terms with flat string, right? And you describe a customer as a customer is a person who buys goods. This works for people, but this is prone to different interpretation and hallucination for AI. Now, in open metadata, customer is modeled as an ontology. Customer has all kinds of relationship. Customer is a person, he belongs to a domain, he places orders, contributes to revenue. Now, AI doesn't have to guess or reason over flat text anymore. It reasons over a formal graph of machine readable concepts, attributes, and relationships. Now, earlier I showed you how accuracy collapses 80% due to context gap in the standard benchmarks. Same model, same data, the only thing we changed is context. The accuracy went up from 10.8% to 76.5%. That is 7.1x more accurate on the hardest enterprise data. These aren't model failures. They are missing semantics failures. A better model won't fix it. You need same model, better informed. The schema alone cannot tell an agent what revenue or active customer means at your company. Your context layer supplies full table column descriptions, usage stats that point AI to the right table to use, ontology for AI to understand the business meaning, metrics on how to measure business KPIs, and we have knowledge center that provides foundational knowledge to AI. That's the context the model needs to write the right query, not just any query. Without this, LLMs guess on raw data. Now, with semantic context graph, they answer your questions, business questions. We are the only approach proven to lift accuracy on sparse, undocumented, chaotic enterprise data because we build the context from data itself. Now, let's come to the third primitive, and that is memory, right? Models forget. Every conversation starts from zero, but the memory compounds. Now, let's look at the data foundation that is built for people today. People working with data develop expertise over time based on their experience. They know which data to use to answer what question, what definition of revenue to use for marketing versus scale, how a report should be presented, right? To your CFO or your CEO. AI doesn't have this luxury. It's like, you have an intelligent person who is working with you, who you have to teach the same thing every time, and that can get very frustrating. Here is the cycle with open metadata. A human or agent acts, a data steward corrects a definition, a user provides certain feedback, an agent classifies a column, an analyst runs a query. These actions are captured permanently, once for all, right? Now, the next set of actions that you're doing with AI is grounded in that prior memory. No re-explaining or doing the same thing again and again with agents. And good thing about memory is it expands across users, teams, and agents. Your data engineer's correction in last March helps your CFO's analyst in November to get the right answer. So while LLMs are getting commoditized, but the memory is the mode for your organization that compounds. Now, that is the foundation, right? The open context layer in open metadata and the 3 primitives behind it. This entire context in open metadata, open source, based on open standards, is available over an MCP server for you to build AI agents. Collate builds an AI agent and assistance on for data on top of this foundation. In the next session, my co-founder Harsha is going to show you what is new on this open foundation and what we have built on top of it with Collate. But first, let's look at some proof points. The enterprises shipping reliable AI on their data today are the ones that built and own their context layer. OpenAI, the pioneering company in AI that heralded this wave of Gen AI, is a great example for this. Their internal data agent, Kepler, serves thousands of employees built on 6 layers of context. And their context layer runs on OpenMetadata. You'll be hearing a lot of details about it in Bonnie's session that is coming up. Now, before I pass it back to Steve, let me just summarize the whole argument in 3 points. In AI for data, the variable is context, not the model. AI for coding works, AI for data doesn't, at least until now. AI for coding works because of context layer available with software development. Enterprise data has none of that. Models keep getting better, but accuracy still stays flat. The gap is context. The fix for AI for data is the open context layer. Most organizations have this brain in pieces, the context, semantics, and memory all live apart. We have benchmarked analytics performance on this context layer and saw a 7x increase in accuracy for enterprise data. Open metadata is the foundation that enables AI for data. One open graph beneath every tool, 130 plus connectors built using open standards. And open is the point. You own your context, plug in any model. And all of this is not just theoretical, right? You will hear from our customers who provide you proof points like OpenAI, Scout24. Now, this is foundational in how data operations and analytics can be done with AI for data. Thank you for attending and enjoy the great, super informative talks that are coming up. Back to you, Steve.
Awesome. Thanks so much, Suresh. That was a great overview. We do have just a moment here before Bonnie joins us. I did figure out the poll, so I'm not sure if you all can see it, but I do have it here. So in terms of the responses from folks, it looks like a perfectly bell-shaped curve where most of you are still exploring, about 43%. About 34% of you have a few agents in production, mostly internal or single purpose. 15 to 16% of you are scaling multiple agents into production, and about 7% of you are AI first. You're going all in and you've got agents that are embedded in how you operate data. So I'm not going to share it on this screen, but again, we'll do a research report to wrap things up. So with all of that, I'm really excited to soon welcome our next speaker. We have Bonnie Xu, who will be walking us through OpenAI's internal data agent, Kepler, which Suresh mentioned, and that supports thousands of internal users within OpenAI. And just to give a little background on Bonnie, she's a software engineer and the tech lead of the data productivity team at OpenAI, where she built an AI-powered data analytics agent from the ground up to help other teams at OpenAI explore and understand data more intelligently. Before joining OpenAI, she spent 4 years at Stripe working on the data platform and previously held engineering roles at both Meta and Google. Her work focuses on building scalable systems that integrate AI and data to make analysis faster and more accessible. So if you would, please join me in welcoming Bonnie Xu to the stage. Drum roll, please. Bonnie, there she is. All right. So good to see you, Bonnie. Thanks for joining us today.
Hello, thanks for the kind introduction, Steve. So good to be here with you all today.
Absolutely. Thanks for making the time to share your perspective with us. I'm going to jump off. I'll turn things over to you to take it away. Thanks, Bonnie.
Awesome. So hello, everyone. My name is Bonnie, and today I'll be talking about how OpenAI deployed AI data agents to help our teams answer questions about their data. So let me paint you a picture. Your business lead comes to you and asks you the question, how many ChatGPT Pro users do we have in Italy? You consult a data scientist, but they're like, actually, this is kind of hard. Let me get back to you. They don't know what table to look at, so they ask another engineer, but the other engineer doesn't know which table is the right one. So after 3 code deep dives, 2 quick meetings, and 5 Slack threads, we finally have an answer. Simple questions like these shouldn't be this consuming and this time taking, but they are. And the reason why this is so hard is because there's so much data. So I'm Bonnie, and I'm here today to talk to you about how we solve this problem. Let me start off with an overview of the scale of our data platform to illustrate why we need an AI data agent. Then I'll go into implementation specifics, the learnings we had, and the next steps we're planning to take. At OpenAI, 80% of the company directly uses our data platform. That's 80% of the company using our team's 15 tools to process over 600 petabytes of data a day, or about 70K datasets. The data is growing rapidly. This means we have so many more questions to answer. But there's more and more data to sift through to get the right result. When ChatGPT launched in 2022, we were asking ourselves, how many users do we have? As the product has evolved, we've introduced more regions, different plans, more features, and now the question is, how many daily active instant checkout users do we have in New York? That's a much harder question to answer now, but fundamentally, we're looking for the same type of answer. One of the reasons why this becomes a lot harder is because table discovery is a lot harder at scale. A common problem is having difficulty finding the right table to use because there's a lot of similarly sounding tables and it's unclear what data is in them. Another common issue is having trouble understanding the subtle nuances of each table. This is a hard problem because some tables have encrypted IDs, some tables have unencrypted IDs, but we still might want to join them. Some tables have columns that adjust for fraud rates, some tables don't. Some tables are pre-filtered by feedback, some are not. Missing one nuance can lead to an answer that is wrong by an order of magnitude. This can be catastrophic when making important business decisions. Not to mention, writing SQL is hard. Who can remember all the different ways we date format or write performance queries or the aggravating fact that Trino arrays are one indexed? So what's a better way of doing this? At OpenAI, we built an internal AI data analyst that takes the full context of data platform and answers these questions for you. At its core, the agent backend service leverages the model to produce AI-powered results wherever you need them. This could be in Slack for answering your business questions, or in your IDE when you're building your data pipelines, or in the web agent when you're looking up different tables, or when you're writing workflows and need data to inform the next action. Let's go through an example. Suppose I'm a data scientist and I'm investigating a huge upward spike in user growth in ChatGPT late March 2025. The first step in reasoning is to check that the spike is real and as I described. So as we can see here, the agent looks at the actual table that stores weekly active user data to get the exact numbers pre and post spike. To make sure it's getting the right table, the agent looks at internal knowledge to understand it. In this case, it was able to find extra context on the table from a Notion doc. It also cross-checked against a dashboard. As the agent is interactively exploring the data, it's checking the different types of data it can get. Here you can tell it's looking at the different data dimensions like plan type and auth status and running queries against those different data dimensions. This helps the agent get more data needed for analysis, kind of slicing and dicing the data, just like you might if you're doing this exploration. As part of the analysis, the agent is trying to come up with reasons why this is happening. In this particular case, it's exploring whether the spike was actually a logging bug due to duplication. These things happen. After some analysis, the agent arrives at the conclusion that it was due to the image gen release. It validates this conclusion by using web search to pull up release docs. And woohoo! This was in fact the right reason. The spike was due to the viral self-anime image generation trend. So how does this magic happen? This is a big overall picture diagram of how things happen behind the scenes. Let's go through each part. On the left are the entry points. On the top are the offline curated knowledge pieces. On the bottom are the sync API calls that the agent can make to our data platform tools. And in the middle is the most important piece. It's the agent talking to the model. Agents without context can give wildly wrong answers, as pointed out in the amazing earlier presentation. Take this example where somehow the agent thought there were 5 million ChatGPT users compared to the actual 800 million answer announced at Dev Day. Just a mining rounding detail, that's all. Here are the different layers of context that our internal data agent uses. Let's start at the bottom with table metadata context at layer 1. As you might have guessed, fitting all 70K tables with their schemas and query history is way too much data to fit in a model's context window. So we need to do some pre-processing ahead of time. Table schema information is inserted so the model knows how to query each table, what columns are available with what types. All this rich table metadata information is surfaced from OpenMetadata and is made available to the agent. Schemas alone aren't enough to understand the semantics and relationships between the data. So we use table query history, table lineage, and code-derived table information to provide this extra context. All of this is transformed into an embedding so that when the agent is running, we do RAG for retrieval. The agent can get information for a specific table or just semantic search over keywords. So that's layer 1. Layer 2 is human annotations, which can be incredibly helpful, especially when starting out and for key tables, and can be collaboratively done via editing table descriptions, for example, in the OpenMetadata UI. So here you can see there's all these great table bits like the schema, the queries, lineage, so on and so forth. We use OpenMetadata's APIs for both online and offline retrieval. In our internal knowledge indexing, we pull useful bits like query history, descriptions, tags, usage, and in online cases, the agent can do table search or live pull groups needed for permissions. It's been really useful for us to have OpenMetadata sit on top of our data warehouse for all this extra table context that is easy to find for both agents and humans. Another thing that people often point out about table metadata is that descriptions can get easily outdated and often become a burden to maintain. And this leads to the agent getting bad results. But it can be really tedious if you're manually updating them, especially when you have so many tables. So we solve this by auto-generating as much as possible. And we also include information beyond what might be available in just metadata, and that's what makes generations even better. And this part is layer 3, the codex enrichment. It's not enough to look at a table by itself as is. You need to really understand how a table is created, where it came from, and this is really the secret to the agent truly understanding the differences between tables, knowing that a table is filtered down because it only came from a subset of logs. And we achieve this by running an offline job that generates codex tasks for certain tables. These codex tasks are launched in parallel and crawl the codebase to understand things like a table's purpose, downstream usage patterns, the exact table grain, and primary keys. So instead of only knowing that a table is for ChatGPT analytics, you know that it's a table that includes only first-party ChatGPT traffic and it's enriched by safety sources. You know that these fields are null and when these signals are missing. For layer 4, institutional knowledge, we have an internal knowledge service at OpenAI that ingests internal knowledge like Slack threads and docs. When fetching, we cache and do permissions checking so that results are fast and gated correctly. This way, we can efficiently get all the right company-specific context to accompany the data. Concretely, this means that when you see a dip in weekly active users, the agent can pull the Slack thread and incident channel that talks about the outage. And this is really helpful when doing the analysis for providing the extra context on the why rather than just the what. Level 5 is memory. Memory is useful for things like corrections and learnings. Here's an example. Without memory, the agent takes way longer to figure out how to answer a question correctly and has to work for much longer. Memory is the mechanism that helps the agent continuously improve and learn. Context will get you 80 to 90% of the way there, but sometimes you need these final little corrections to get the right answer. For example, you just need to know that a particular ChatGPT product is filtered by this random string. That's just the value, and that's just how it is. We make memories easily available and accessible so anyone can contribute to make the agent better. In a conversation, the agent itself or a human can save a memory, and there's two scopes, global or user. These scopes are important because users might want their own customizations or the data is potentially sensitive. And based on a conversation, the agent will also proactively suggest memories, and users can confirm their insertions. And if all of this offline information isn't enough, we also have our last layer, which is runtime context. The agent can make live calls to our data warehouse or any other data platform service it needs. So we can talk to Spark or Airflow or OpenMetadata. It's just a short API call away. One example of when you might use this is if a table is new. So, you generated this new testing table and you want to compare it with an existing table, and the agent can just directly run those queries live. And I just really want to drive home this point that models are really smart, but they're not the full answer, and context is really what makes the difference. The next important factor to consider is how we ensure we don't cause regressions, and let me talk about how we measure response quality. Our evals consists of sets of question-answer pairs. A question is usually some important metric we want to get right, and then we have manually curated expected sequels that will generate the correct answer. And so we hit our agent query generation endpoint to turn a natural language question to generate SQL and run the query, and then we do the same with the expected SQL, and we compare the results after. All of this is fed into the OpenAI evals grader. And a lot of times, even though the generated SQL can be slightly different, it can produce the same results, or an extra column doesn't meaningfully change the answer. But all of this is taken into account with the final grader that yields a score and a reason. Here are some key takeaways specific to our evals process. Exact SQL text equality is not a good representation of whether a SQL eval passed. So we normalize functions, aliases by converting everything to its ESC representation. This helps us get around SQL syntax things like different date filtering. And when comparing result sets, we also give wiggle room for things that might not meaningfully change the answer. Like, sometimes a float or an int, it's not meaningfully different. LLMs are also really good about reasoning about failures. So instead of being prescriptive about a certain thing, the model grader does a much better job of finding the actual differences that matter in the context of a question. And looking at the chain of thought for evals was really useful to help us more easily debug failures. Data security is something we also take very seriously at OpenAI. Users should only be accessing the data that they have a legitimate business purpose to do so. When we ingest internal knowledge, we ingest sanitized queries so that important IDs aren't accidentally leaked. Sometimes users, who rightfully should have access, do need to see the sensitive results. And in this case, we link a web page where we check that the users have access to the underlying table. And the same permissions checking model is used when users share an agent chat. Sometimes when a user needs to access a certain table they don't have access to, they can see the right groups in the OpenMetadata UI. And just like a human, an agent can also make mistakes. This is why we stream the agent's chain of thought as it is answering questions. So at the end, it provides assumptions and the steps it could take, so you can sanity check its every move. If the agent ran any queries that resulted in the data you're seeing, those will also be linked, and you can always directly click into the raw results. Now I'm going to talk about some lessons we learned along the way. It turns out that if you give the model too much information, it gets confused. For example, we have a lot of tools that we expose to users, but some are doing similar things and have overlapping functionalities, which is okay for a human who's just directly calling them via an agent, but when an agent's doing it, it becomes a little bit more tricky. So restricting tool calls really helped. We also found that the model wasn't very good at consistently calling all the tools it had available, despite it being mentioned in the prompt. So combining multiple tool calls to force this also helps a lot too. We also realized that specific instructions actually yielded worse results. there are so many different types of questions people ask. And while there is a similar general overall path, there's a lot of little branches in logic. So being overly prescriptive actually hurt us because the model would try to follow these exact set of instructions that didn't really make sense for the question. So changing our system prompting to be a little more general so that the agent gets a rough starting point, but then, we leave the reasoning to GPT-5 really helped us because at the end of the day, it does have a lot of great context. So how can you get started if you're trying to do something similar at your own company? Firstly, the most helpful thing to us starting out was leveraging existing APIs. A lot of model platforms like OpenAI have this tooling just directly available. No need to reinvent the wheel if it already exists. Using OpenMetadata for feeding rich table information as part of our context layer was also helpful. Another thing we leveraged heavily when building this out was Codex. With the small team we had, Codex was crucial in getting something out the door and iterating quickly with users. And this sped up development so much and has continued to be really useful in accelerating our engineering workflows. So that was a lot of me talking. Thanks for not falling asleep. If there's anything you take away from this talk, I hope these 3 things stick with you. Remember that it's really important to have context beyond just table metadata. Code-enriched context and company product context really goes a long way. Also, incorporating memory is really valuable so your agent can continuously improve. And finally, evals are the way to make sure that your model can stay consistently good. And that wraps up my presentation. Thank you so much for listening.
That was awesome. Thanks, Bonnie. I appreciate you going into all the detail on that. We do have a couple minutes. I've maybe a couple questions I could ask you, if that's all right. So you talked about taking repeat queries from 22 minutes to under 90 seconds. And you talked about the memory and the self-learning that was crucial to that. What was the hardest part to get right? Was it the memory layer and getting the technical side set up, or was there any, education you had to do with users for them to understand what was going on in the back end so that they felt comfortable getting the results? I'm just curious how much was enablement versus the technical piece, and which was hardest for you?
Yeah, honestly, there was a little bit of both. I think we definitely, to have people even just adding memories and contributing, there was a little bit of user education we had to do just so that people were aware this even existed and that they could, meaningfully make the model generations better. But I think after they understood that, a lot of the heavy lifting was more in the actual, the framework for retrieval and, getting that right. And so I think the combination of the two really helped with the generations.
Awesome. Last question. For a data team that's nowhere near maybe the size and scale of OpenAI, is there one design decision for Kepler that you tell that team to copy first? What's the most important thing to think about if people are trying to build their own internal AI data agent?
Yeah, that's a great question. I think, every company's data platform is so different. And so maybe one piece of advice that could be generally useful is really about, I think what was most useful for us in the beginning was quickly iterating. I think when we started out, we didn't actually know what would have stuck. It was a lot of iteration, trial and error. But I think the most important thing was, okay, we knew that we had to get, there's so much data, there's a lot of curated context that has to be in there. And then from there about, tweaking about how we got it or, trying out different experiments is really helpful.
Awesome. Thank you for sharing that. All right. Thanks again for sharing this. It's great to see that, what a leading frontier lab does. Saw the news about OpenAI finally to go public. So congratulations and good luck with all that. So thanks again for joining us today, and we'll move on to the next session and look forward to chatting with you later today.
Thanks so much, Steve. Bye, folks.
All right. So before we move on to the next session officially, I would like to open up one more poll to the audience. I think I've got things figured out now. So on the right-hand side, you should see a poll that pops up. Poll number 2 is, what's the biggest barrier to getting AI into production at your organization? We talked about where people were in their journey. Now, in terms of what might be some of your barricades, is it getting data quality and trust right? Are there wrong answers due to a lack of, is it the hallucinations that you're worried about, the lack of semantic context for AI agents? Option C is governance or regulatory compliance. That can also often be a, I don't want to say cultural, but a regulatory concern that people have with doing too much with AI too quickly. Tool complexity is another option, or finally, shortage of talent or skills. Now, it could be multiple, so if you could just pick your top barrier and share that, I would love to try and see if we can get this published out to everybody. I'm going to go into this poll number 2 myself and see if I can pick on something. All right. So I do see a lot of responses coming in. There's a lot more of you out there than what I see responding to the poll, though. So if you can check that out, hopefully there's a tab at the top or something that says polls, and you should see it live. All right. So I'm going to go ahead and see if we can show the results for this. All right, so I think you should be able to see the results. So it looks like, oh, I see, number of votes. Well, it's a pretty dead heat between data quality and trust, wrong answers due to lack of context, and governance and regulatory compliance, sort of neck and neck as the top 3. It looks like everybody's got plenty of talent and skills. Only 5% of you noted that as an issue. And we've got tool complexity and integration, about 8.7% of you seeing that as a challenge. So very interesting, very interesting. I think the polls should stay live. You should be able to view those or comment on those as we go. So wow, what a great session from Bonnie, though. Thanks again to her for joining us and sharing that information. Very exciting time to see what people from the top are doing at the Frontier Labs. So next up, I'm really excited to talk with Harsha Chintalapani, our CTO and co-founder here at Collate and the OpenMetadata project maintainer. Because as you saw from Suresh and Bonnie, AI is really revolutionizing what's possible, both from data operations as well as the analytics. It's not just for the end users, but we're spending a lot of time thinking about how do we enable AI agents to take the manual tasks off of people's plates, the day-to-day data engineers, data practitioners, data stewards, governance professionals. So you can go away from ticketing queues and that sort of thing and just have a conversation with your data if you get the things in place. So Harsha is amazing. He's a longtime builder and has previously led teams to productize big data systems at Hortonworks, Mozilla, and more recently built Uber's Kafka system to scale to 5 trillion events before founding OpenMetadata and Collate with Suresh. So Harsha will walk us through how Collate 2.0 delivers on that AI for data promise for data teams to be able to rethink how they do data operations and analytics using AI agents that can help with a lot of that automation of those manual tasks. We'll be talking about a new context center that unifies knowledge across the systems, similar to some of the things Bonnie was talking about, and automations that can bring data directly to the people that are driving decisions. So I'd like to welcome on stage, if you would please join me in welcoming Harsha on. Harsha, great to see you. I'm going to just turn things straight over to you. Harsha, take it away, please.
Harsha, CTO and co-founder of Collate and OpenMetadata project maintainer. So before I get into what's new, I want to start with a thank you. OpenMetadata is the #1 open source context layer for AI. But that is not just because of us, it is because of the community. More than 450 contributors have continued to build OpenMetadata on a daily basis. And our large deployments continue to grow, right now at 4,000 across the world. And the community is at a breakneck speed with 14,000 GitHub starts and almost nearly the same number of members in Slack community. And the 50 million Docker downloads tells a story that this is not just a project, this is becoming an infrastructure. Every connector contributor, every issue that is open in the GitHub, every deployment tested in production, every conversation in Slack, this is what shaped OpenMetadata into open context layer for the AI. And the word open matters to us a lot. The context layer for enterprise AI cannot be locked inside one vendor. It has to be something your data teams, your platform, your agents, and your ecosystems can all trust, extend, and build on. That is what OpenMetadata is. So before we talk about 2.0, before we talk about Collate AI, before we talk about where is all of this going, genuinely thank you. So none of this ships without you. Now, let's go on to the exciting chapter. Today, we're going to talk about OpenMetadata 2.0. There are 3 big advances in this release. The first is the context center. This is a unified place for all of your context your data teams and AI systems need. The second is the semantic and ontology foundations. Glossary relations and the ontology explorer. This is how we move from flat business term to a connected graph of meaning. And the third is memory primitives, an open object model that lets your organization memory live directly in OpenMetadata. This is a big shift. OpenMetadata, not just a place for your metadata to be stored, discovered, enforce data quality and observability. It is the open context layer for the AI and humans. And this matters because AI does not become useful in enterprise just because you connect to a database. It becomes useful when it understands the context around the data, what it means, who owns it, how it's used, what rules apply, what people have corrected before, and what your organization has already learned. So this is what we are building into OpenMetadata 2.0. Now, the first big rock is context center. Context is one place to bring every form of context to your AI. There are 3 layers to here. First is the knowledge center. This is the home for articles, quick links, and the documentation your team already uses every day. Not everything lives in a table descriptions. Some of your most important context lives in docs, runbooks, policies, onboarding pages, decision logs, and team notes, so on. Those all now can bring it into OpenMetadata. Second is the document uploads. You can upload PDFs, images, CSVs, spreadsheets, policies, contracts, specs, you name it. OpenMetadata extracts them, understands them, and vectorizes them so agents can reason over that knowledge. This is important because a lot of enterprise context is not in the warehouse. It is in the documents, it's in the contracts, it's in the policy file. It's in the things teams already created, but AI could not previously use in a governed way. And that is the most important part. I think Bonnie gave a really good implementation of how memory helped them, right? That's exactly what we're bringing into OpenMetadata. The context memory. This is where the system starts to learn from how your team works. Let's say a steward corrected a definition, an analyst clarified what metrics is, an engineer explains why a join is wrong. The correction does not disappear into a chat thread. It becomes a memory, tagged to the asset and available to the next person or agent, whoever touches the data. That is a compounding effect. The first person fixes the context, the next person can use it automatically. And the important point is all of this is open in OpenMetadata. The second most important thing here is the semantic foundation. Today, if you look at the glossaries or any of this implementation, most of this is still flat list. You have terms, you have descriptions, maybe you have owners, but the system does not really understand how the concepts relate to each other. It's not enough for AI. For AI to reason over your business, it needs to understand the meaning. It needs to know one concept is part of another concept. Let's take an example of revenue and gross revenue and net revenue, how they're all related. These are the terms, these are the glossary relations that you get to create within OpenMetadata that make sense within your organizational context. Right? A net revenue is derived from gross revenue. Net revenue calculated from gross revenue. This is where how the glossary terms and the business concepts come together to define not just what the definition is, how they relate to each other, how the concept relate to each other. The next part of this is Ontology Explorer. This lets you visualize and traverse your business vocabulary as a graph. You can see what is connected, what is derived, what is governed, what is isolated. It's powered by OWL and stored in an RDF store. Now, the best part of that is not only your team members can understand how the terms are interlinked, what is the relations, your AI agents can also reason over with this. And everything is RDF mapped, open by design, and we built on top of ontologies based on OWL, and all of the relations within the OpenMetadata, such as your metadata itself, is represented as knowledge graph or RDF. This becomes a semantic layer for not just for humans, but also a reasoning layer for the agents. That big rock is the memory. This is one of the most important shifts in the release. Every enterprise has organization memory. People know which table are clustered. They know which metrics are confusing. They know which joins are dangerous. They know which dashboards are outdated. They know that weird exception that only one team remembers. But that memory usually lives in people's heads, in Slacks, in tickets, in old conversations. Obviously, AI cannot use that reliably. So in OpenMetadata 2.0, we are making organization memory an open object model. There are three things to know. First one is, all the memory are first-class entities in OpenMetadata knowledge graph. They are tied to a user, the thread, the use case, or the specific data assets that involved. That means memory not just a chat transcript. It's structured, reusable, and in the governed context. Memory can be captured through APIs, MCP, or chat. A steward can correct something in conversation. An agent can flag a join pattern. An SD can write memory programmatically. But every channel writes to the same graph. That is the key. So there is one memory layer every agent can inherit from, and every user of OpenMetadata can take advantage of. This is where organization mode compounds. Not because the data is locked in, but because the knowledge keeps getting better based on the conversations that are happening around the data. So everything I have just covered is the open context layer. Right? That is the step one: context center, semantic foundations, memory primitives. Together, they make OpenMetadata the open context layer for AI. But the step two is the bigger question. What exactly are you going to do with it? Everyone today starts saying context, but almost none of them answer the question, what does context actually enable? So this is where Collate 2.0 comes in. Collate 2.0 is the AI for data teams built on open context layer. OpenMetadata provides the open foundation. Collate turns that foundation into AI native experience for people who run the data estate. We're shipping a lot of new features on top of open context layer. I'm going to walk more detail into that, but to start with, we want to build around AI native experience for the data teams. We want to solve data use cases for the data teams. There are pre-built agents that do the work. There is conversational UI across the product, memory that learns, and the ability to build your own agents based on the governed context that we are making it available through the OpenMetadata. So everything that we just announced in Collate 2.0 sits on the foundation we have been building for OpenMetadata. OpenMetadata is step one, the open context layer, metadata, lineage, quality, you name it, including the glossaries, ontologies, knowledge graph based on the RDFs. But the context layer is not the destination. That is the Collate 2.0. Collate activates that context into AI for data teams, AI that does the work, conversation as the interface. OpenMet makes the context open, Collate makes the context actionable. That's a shift from metadata to AI for data teams. So now let's take a little bit of kind of the journey of ours, right? So if you think of OpenMetadata previously and Collate, we are helping data teams to organize metadata, govern the data better, data quality, data observability, all of these things coming together under one roof, one platform. And we built along the way a lot of AI agents to help accelerate this work, which is your documentation agent, your data quality agent, your tiering agent, and so on. With Collate 2.0, we want to kind of make AI doing the work. Think of before, user had to navigate to UI, find the things. Humans and the agents, for example, auto classification agent, tagged, classified, and documented assets for you. Glossary terms were entered by the stewards, agents query the APIs for metadata. This is the old model. The new model is user can ask questions in natural language. Tag become interface. AI agents can tag, classify, document, and enrich at scale. Glossary terms are generated from data and approved by your teams. Agents are built on top of this context. And memory compounds your team's knowledge across users and agents. This is a shift from raw data to information, to knowledge, to meaning, and to intelligence. And the bridge is the context, semantics, and memory. That is what makes AI for data different from just putting a chatbot on top of it. What exactly are we shipping? So these are the 6 capabilities that we're shipping out of the box for 2.0. And all of them, again, sits on top of open context layer. The first is AI native experience. Here, chat replaces navigation. We are talking about headless UIs and everything else, but we believe UI is still important. But we want to reduce the cognitive dependency on your team learning all the pieces of the UI itself to access various different capabilities. We want to bring the UI into the chat. And that is one of the cool things that we have done in 2.0. I highly recommend you to stick around to watch the demos in the later sessions. The second is the AI Studio. We're building a lot of agents, but you can build your own agents on top of the context layer. No code, grounded again in the government metadata. So agent can reason over your business, not generic more idea of your business. The third is the plugins and skill. Context does not live in your warehouse. It lives in Notion, Confluence, GitHub, Slack, and so on. Plugins and skills brings that knowledge into Collate, so agents can reason over with it. The fourth is the automations. What we are doing on a repeated basis, how can we automate this part? One of the automations could be, hey, can I get a report of analytics that my team member is doing on every Monday morning? That is the part of the automations where natural language can help you automate not just governing the metadata, but accessing your data and generating the reports out of it. The fifth is the memory. Every preference, every correction, every piece of tribal knowledge can be captured, tagged, reviewed, and reused across the users and agents. The system gets smarter the more your team uses it. The sixth is the collaborative chat. This one is the one that is the hardest to replicate elsewhere. Humans and AI agents in one group chat. Your data engineer, your analyst, your steward, along with Collate agents, working on the same problem in the same conversation. Now let's dive deep into each of these features. So the first pillar is the AI native experience. The chat, the Ask Collate becomes like a new front door. In previous iterations, user had to know where to go. In 2.0, the user just asks. A steward can say, hey, document this table. Analyst can ask, which customer metric should I be using? A governance lead can ask, show me the PI assets in the domain that do not have owners. Collate routes this request with the right context, checks permissions of that user, finds the right assets, generates the query for our workflow, and returns the answer. This is conversational data management. There is no UI hunting, no form filling, no custom syntax. The second part of this experience is the natural language automations. You can create documentation, tiering, ontology tagging, data quality checks, and classification workflows in plain English. Not just that, you can actually talk to your data, generate analytics, and send it to your Slack, your MS Teams, or your email, wherever your team works. The third part is the shared chats. Team build on each other's work. A conversation no longer disposable, it becomes reusable asset. It can capture decisions, corrections, context, and memory. This is why 2.0 is a different product experience, and 2.0 is for everyone who works with data. One of the places this becomes really powerful is analytics. A team lead wants to understand a pattern before it becomes trend. Analyst wants to know why a metric moved. A business user wants an answer, but does not know which dashboard, table, or metric to start with. These are exactly the questions that often get stuck in the backlog when the data teams test them. Collate AI Analytics built to answer them. The user asks a question in a simple natural language. Collate uses the context layer to understand the business meaning. We have the clustered assets, the governance rules, the available metrics, including the user's permissions to access the data inside those assets itself. Then it can generate a governed dashboard in a single conversation. This is where semantics matters. Again, as Suresh was talking earlier, adding semantic context lifted execution accuracy from 10.8 to 76.5. And we use this to test the Spider 2.0 Snow subset. That subset is actually represents what happens in enterprises today. The data is not properly tagged. The column names are really confusing. The schema itself is not well even maintained. The joins are not explicit, not easy. So you cannot just throw a model at it and say that, hey, let's see how good of a text to SQL it can do. It's more than a text to SQL. This is actually to build analytics on top of the governed context that we are building. This tells us something very important, right? The future of AI in data is not just better prompts, better models. It is better context. The model performs better when it understands the business layer of the data. That is exactly what OpenMetadata provides and what Collate activates here. The next pillar is memory. As we talked earlier, this is the OpenMetadata primitive made it into product experience. The first part is capturing conversation. Let's say a steward corrects Ask Collate in chat. Maybe the system used the wrong metric. Maybe it misunderstood a definition. Maybe it selected a wrong table. That correction becomes a memory automatically. It's tagged to the asset. It is attributed to the person. It can be reviewed. It can be reused. The second part of this is the memory itself is personalized and persistent. The memory is user level. Maybe I prefer revenue reported over net refunds. The memory is at data asset level. Maybe a table has a known caveat. The memory is domain level. Maybe a finance team has a standard definition that should apply everywhere. The system gets smarter as your team uses it. And the third part is governed feedback loops. The memory nuggets are editable, attributable, and reviewable. There is a difference between enterprise memory and a chatbot remembering random things. This is not just a memory, it is a governed memory. Tribal knowledge nodes become shared infrastructure. So your data engineer's correction in March helps your CFO analyst in November. That is the component loop that we are talking about. And the most important pillar is the data access workflows. So AI for data cannot ignore governance, right? In fact, AI makes governance that more important. If agents are going to find data, generate answers, run workflows, and more importantly, in Collate, it acts on behalf of the users. They need to follow the same rules humans follow. So with Collate 2.0, we bring this access into the same flow, from asset to access in one experience. The marketplace surfaces domains, data products with one-click request. Users get a self-discovery, but access remained governed. So you have end-to-end workflows. A user can come in and say that, hey, I found this data asset. I do not have an access to it. They can request access. They can express the business use case behind that request. They can set the timeline for that request. And the owners of the tables or the admins of the platform can review and create, automatically create the policy approval, the request. And more importantly, all of these access requests are auditable. It's a multi-step, it's conditional with human in the loop. And most importantly, agents play by the same rules. An agent requests access to the same workload a human would. And it follows the same audit process, same approval process, and same controls. This is how the governance scales. It stops being a gate at the end of the process and becomes a workflow built into how people and agents can work together. If Ask Collate is the agent we shape, AI Studio is the agent factory you operate. This way, teams can build their own fleet of AI agents, deploy them natively into their workflows, but again, grounded in the context layer, not floating on any generic LLM. There are, again, three important parts here. The first is the plugins and skills. Plugins are the building blocks. They let you the plugins and skills are the building blocks. They let you compose custom agents that know how to work across your systems. But unless there is a UI-based editor, they can create agents without writing any code. For engineers, we build AI SDKs. It's available in Python, Java, and TypeScript. So they can build deeper integration into production-grade workflows. So we're not saying there is one agent that solves every problem. We are saying bring your own workflows, bring your tools, bring your team's way of working, and compose agents on top of the governed context. That's the AI Studio with plugins and skill. We're also offering the bring your own model, bring your own keys. Enterprise do not all want the same model from the same vendor, same deployment patterns. Some teams want OpenAI, others may want Anthropic, and some are standardizing on Bedrock or Vertex. Some need their own keys, their own policies, their own routing. AI Studio is built for that reality. Bring your own model, bring your own keys, bring your own policies. And third, and the most important part of this is the inherited governance. This part, what that makes enterprise great. Every agent automatically inherits the context, the lineage, the access control, the audit trail from OpenMetadata and Collate. So when you build an agent, you're not rebuilding the governance from scratch. You're not asking, can this agent see the data in a separate system? You're not manually wiring the audit logs. You're not building compliance on later. The agent inherits the same rules that already govern the data estate. That is a big difference. Collate is the agent we ship. Again, AI Studio is the agent factory that you can build on. Now, bringing all this together, here's the full picture. I'm going to build it from the ground up. So OpenMetadata already connects to more than 130 systems across every cloud, data, and BI platform, warehouses, lakes, and so on. Everything you have connected. And it's built on the open standards. From the very day one, we built OpenMetadata in open source with the open standards, with JSON schema as the founding layer for how to define metadata, how to design metadata across different systems and different attributes. We introduced RDF, DCAT, and DPROD to enable knowledge graph on top of this metadata. We're also investing heavily into adapting to open standards that are already popular and adopted by the industry, such as Open Data Contract Specification, Open Data Product Specifications. We also built into Open Lineage, so you can submit events in real time. And everything here is available through an MCP server that is enterprise grade with access control enabled by default. This matters because the context layer cannot be a proprietary plumbing. It has to be open. And above that sits OpenMetadata. This is the open semantic context layer for data and AI. As three primitives, the context, technical metadata, schema, quality, and data observability, lineage, and so on. Second is the semantics, business meanings, glossaries, ontology, metrics. Third, the memory, conversation, history, all the corrections that your teams are doing, the feedback loops. That is the foundation for every winning AI architecture needs today. Not just data, not just metadata, context, semantics, memory together. About that, we build Collate Enterprise. This is the production runtime. This provides you with analytics and operations, gives you connectivity and security. This is what makes that open foundation enterprise grade. And about that, there are two ways to consume the platform. On one side, you have Collate AI, the native AI workspace, an extensibility layer, plugins, scales, automations. On the other side, you have external agents. You probably is running through Codex. You probably is using Cortex or Claude or Genie, any agents that your teams are already using. They can connect through MCP and the AI SDK. Same context, different nodes. That is the architecture. Now, OpenMetadata is the open context layer. Collate Enterprise makes it production grade. Collate AI turns it into AI native experience. And at the top are the use cases that unlocks data management, data products, analytics, AI governance, anything a data team would like to do today with the data, everything enabled through the doors of the Collate AI. It's all built on OpenMetadata and powered by the Collate AI. Before we go and say that he's that all we built, not just that, there's one more thing. Everything I have shown so far is about making AI useful for data teams, giving it context, giving it semantics, giving it memory, giving it workflows, giving teams a way to build and operate agents on top of governed data. But there is another side to this. The more capable these agents become, the more important governance becomes. Because if AI can discover data, generate queries, request access, write metadata, run workflows, and coordinate with other agents, then we need to know exactly what is running, who owns it, what data it touches, what policies apply, and whether it was approved. So the same context layer that makes AI useful also makes AI governable. And that brings us to AI governance. So AI governance is the next big governance problem. Suresh made it point clear earlier. AI governance is going to be 10 times worse than the data governance. And because you don't know how the model behaves, where it accesses the data, what kind of data it has, and what access it has, to solve that, you need systems, you need inventory, you need approval workflows, you need policies, you need audit-ready evidence of where all your AI systems is touching. So we are building a system that lets you govern AI assets the same way companies govern security, controls, compliance records, and data control. The first part of this is the AI asset registry. We can document every LLM in use, every MCP server, every agent, every AI application. All of this registered in one place with the governance attributes that matter. What region does this AI application runs in? Does it touch any customer data? Is it used for training or inference? Who owns it? What policies apply? So on. Intake and approvals. Every new AI asset goes through the same custom intake process that you define. You set the questions, you set the approvers, you set the risk levels. And finally, the framework appliance. You can enable EU AI Act, your own internal AI policy, or any custom framework your organization needs. Each framework can specify required properties, approval routing, risk classification, evidence requirements, and so on. And we track that at every asset level. And the goal is when an auditor asks which AI system touched the customer data, you can answer out of the AI governance. When legal team asks which agents are operating in the EU region, you can answer that. The same source of truth, same workflow, same audit process. So this is where the industry is going. The old category of metadata catalogs, find the data, see who owns it, understand where it came from. This was useful but passive. OpenMetadata changed the game by moving the category into a unified metadata platform, bringing metadata, lineage, data quality, observability, governance, and so on. Most importantly, collaboration together in one open platform. That's the step one, make data usable, trustworthy at scale. Now, AI is pushing the category further. AI needs more than metadata. It needs context. It needs business meaning. It needs semantics, ontologies, knowledge graphs, memory, policies, and so on. So the journey is metadata catalog to unified metadata platform, where we revolutionize that category. Now onto open context layer, the AI control plane. So if you think of level one is a governed foundation, level two is where we build AI-assisted workflows that can document, that can generate data quality tests to enable fast adoption of governed data. Level three is the AI native metadata platform that we're going to show, that I just talked about, and we're going to show in our demos later, where agents help users to find and consume and access the data. And level four is the autonomous agent orchestration. You have more agents to build, not just what we ship. How can you build on top of the context layer that we are building? This is where the Collate 2.0 takes you. OpenMetadata gives you the open context layer. Collate turns it into AI control plane for data teams. And finally, I want to kind of leave it at this note is we have been making this argument for some time now. AI does not fail in the enterprise because models are not smart enough. It fails because models do not have enough context. And now Gartner is making the same argument independently. In the recent data analytics and summit in London, they said semantics, context are the brain of AI. This is exactly right. We agree. Without context, AI agents hallucinate. They introduce bias. They produce unreliable results. Traditional schema-based models are not just enough anymore. A column name, a data type do not tell an agent what a metric means. They do not tell which definition finance trust. They don't tell which dashboard is certified. Gartner's explicit advice is to establish a context layer as core infrastructure. And their prediction is by 2027, organizations that prioritize semantics will create agentic AI accuracy by up to 80% and most importantly, reduce the cost by 60%. And that is the category, that is the infrastructure layer that every enterprise will need. And that's the open context layer. Context, semantics, memory is exactly what we have been building in OpenMetadata.
Awesome. Thank you, Harsha. We've got to move on to the next session. Anything else you wanted to close with?
No, I think we summarized what we are building today, and we are really excited for the demos that's coming in. It shows everything that we have built in action. So please come take a look at our demos. It'll be really exciting.
That was awesome. Thanks, Harsha. Incredible pace of innovation. Appreciate it so much. All right, next up, we've got customer lightning talks. I've got two amazing presenters, Angelita Frozza Sanchez, the head of data platform engineering at Scout24, and Amy Forrest, who's a software engineer from Yelp. It's 15 minutes each session, so I will do my best to do some quick introductions. First up, we're going to have Angelita. She is managing a multidisciplinary team and has led initiatives such as transitioning from a legacy data catalog to a semantic, agent-driven approach, as well as implementing integrations and automations to improve data accessibility. Her work spans infrastructure, governance, data engineering, and AI, with a focus on enabling data and analytics capabilities across the organization. Angelita, so good to see you. Thank you again for making time with us.
Hi.
I know you have such an incredible presentation today, so thanks so much.
Hi, good evening. Thanks for having me here. It's a pleasure to talk to you all. So I'm Angelita. I'm here today to talk to you how have we turned our institutional knowledge into trusted AI context by powering a context catalog at Scout24. But first, you need to understand who we are. So Scout24 is the leading real estate company in Germany. And it's the mother company of several different subsidiaries. We have companies in different sectors with marketing, acquisition, CRM software, data, finance, valuation, and training. With this ecosystem, you can imagine how much is scattered and different our data is, because each of those companies still have their own platform, not always, but most of them, with their own technologies, different formats, and so on. Imagine how do we make AI to understand this whole context. This is what I explained to you today. At glance, we were founded in 1998. We have offices in several different German companies, cities, and also in Austria. We have B2B and B2C customers and around 1,100 employees, and we are DAX listed. So I'm leading the data infrastructure and governance function at Scout24, and in our team, we do have a vision. We want to have the foundation for trusted data and AI at scale. But this is not just something easy to build, because we want to make it available in a way that no training is required, no technical barriers, and people are able just to get their insights. We want people not need to know SQL to query the data. We want them to talk with AI and get the data that they need to. And we want to do this with high trust, operational efficiency, costs, and then we can have the AI that people can trust. For all of this, semantic, context, all of this is key. To understand how big our challenge is, you need to understand how our infrastructure or architecture looks like. So at Scout24, we have two key personas, not the only ones, but the key ones. We have data producers and data consumers. So basically, software engineers are data producers from key systems. They can simply post the data that they produce to our data lake. It's not that simply, because we do have contracts in place. They need to describe their data. They need to make it in a YAML file. They need to describe which team they are, which table they are sending to the data lake, the fields, types, descriptions, and PII information, for example. All of these go to a landing zone. Then we have an internal service that will validate this against the contract that was made by the data producer. And if things match, we just move this data from the landing zone to raw data layer. And of course, we use an open format table, which is Delta. It sits on a Glue catalog. Then we query our data with a Starburst. Also, data consumers can build reports using currently MicroStrategy, or talk with our LLM of preference. Nowadays it's ChatGPT, to get their data. We have MCPs running on top of Starburst, for example, that allow the customers to get data without knowing SQL. But it's not as simple like this, because as my colleague said before, simply allowing LLMs to query data without context leads to a lot of complications. And because of this, we have Collate as our governance and context catalog. And I will show you what we have done to make Collate this powerful context catalog that lends and it stays as the base of our platform nowadays. We created a concept that we call AI virtual cycle. So as my colleague said before, companies hold a lot of knowledge, and knowledge don't sit in one single place. We have different places where we can get knowledge from. It's like team communication tools, documentation and knowledge bases, code repositories, different database systems, file storage, and even external sources. And then when we start to build this context catalog, one aim that we had was to reduce the overload that our users had in the past, because data governance, documentation, knowledge management, it's not a new thing. We always had this big ask to data producers to document the knowledge, or data owners to document their knowledge, document their data sources. But it was a very hard work, first to produce this manually, second to keep it up to date. So with this in mind, the first question that we try to answer is like, how do we do this as so easy that people keep doing this? Then we decide to first not ask people to do that. We just create MCPs on top of existing knowledge sources. And then we use LLMs to enrich this source or make meaning of this. And the same LLM with Collate MCP connected, we use it to ingest this documentation that was generated inside Collate. So we generated, when was not available, table descriptions, column descriptions, PII classification, lineage, certification, if it's bronze, silver, gold, or the tiering of the data. We ingested also usage for the objects, because this is also context. But then when we made this, we create this cycle because we use AI to enrich the context that will be consumed by AI. We had the concern of the transparency. How do we make transparent for the one that is consuming that this information was or AI enriched or AI generated? And for this, we create some workflows that I'll show with you. So here you can see how the system works in practice. We have our source of information, each source that we consider legit. We publish an MCP on a central MCP server. This is approved, validated, including our Collate MCP. Then we have our LLM of choice that will read from those sources and also generate and enrich the documentation through Collate. And we have an end user workflow. So the end user, when they see or they query that information, that context in Collate, they will see a tag that this was AI generated. And if the owner of that entity, of that domain, review that information, they just remove the tag. Because this information will be, of course, reviewed by the human, published as original documentation, and then the Collate MCP will also make this information available to our data agent, for example. We have internal data agents that have certain priorities when looking for data. They don't start generating SQL. They first look for context in Collate, for example. And then when the agent gives an answer, even if the answer was a result of a query, the end user will see a confidence score on the bottom. And this confidence score is calculated based on how much context the agent got and how much creative the agent was to give that answer. So as less context the agent will find inside our trusted sources, lower the confidence will be, and the end user will see this in the answer, and then they can judge if this is a good answer or not. And we also have information to enrich our context later. And of course, this brings a lot of benefits, more accurate answers, higher confidence, transparency, and trust that is governed in a single source of truth. During this journey, we learned some things. So we all discussed here this evening that governance and context were always needed, but now it's for a different outcome. Now we need to build governance and context for both AI and humans, and they have different needs. Not every source of institutional knowledge is a good source of truth. When we started this process, we started, let's put everything inside the model and see what comes out. And guess what? We learned that not everything or has the same level of quality or has the same level of trust or relevance or the same level of information or the same format. Format also important because your costs can be very high if it's not well structured for AI consumption, for example. And also on the human aspect, one thing that is important is that things have been changing so fast. Users have a lot of new tools every day from the external environment and also from internal teams that now produce things faster. And they have context overload. And we need to help them to navigate through the change and to adopt the new tools and the new ways of working. And also, one thing that I would like to leave you this night with is one sentence that is key for me. We all talk about AI, but the real product is not AI. Context is the real product. AI just multiply it. And this is what I would like to leave you all today. I hope you like it.
I love that. Context is the product. AI is the multiplier. It's a new world we're living in.
Yes.
Thanks, Angelita.
You're
We
welcome.
do have a minute or two here before we bring Amy up on stage. I'd like to ask you a question if it's okay.
Yes, of course.
Awesome. You described the AI virtuous cycle, which I think is brilliant, where every interaction is compounding that knowledge. Was there a sign that you saw when this was actually starting to take place that the system was getting smarter on its own? Was it a gradual rollout, or what was the process you went through, and where did you really start to see this cycle take off?
Yeah, so we had this first interaction, of course, this first wave of excitement that we decided, let's put everything there and see what comes out. And then we experienced some good answers and some not very good answers. And of course, the key was when we started to enrich the context, right? So when we put Collate in the hierarchy for the answers and say, first check the context, then decide how to build our queries, this is where we saw the improvement. And now we are in the second wave to get even better answers. We are now testing the synonyms and how enriching synonyms can help the agents to get better answers.
Awesome. Very good. Thank you so much. Again, appreciate you sharing that. I know we'll have you back here very shortly for the governance panel. So looking forward to seeing you again. All right. Next up, I'm very excited to bring Amy Forrest up on stage. She's a software engineer at Yelp who is driving better data user experience within the core data platform group. She is a former data scientist turned platform engineer who builds with the end user in mind, having once been one herself. And her work sits at the intersection of data discovery, metadata, and responsibly applying AI to organizations' data where trust and correctness are critical. And she'll be talking about how to cover the switch, or how she switched to OpenMetadata, the selection process they went through, going from a Docker POC with over 100 to an environment with 100,000 entities in production, and the custom engineering required, which includes extended connectors, usage stats, certification, search algorithm tuning, and LLM enriched assets. So please join me in welcoming Amy to the stage.
Thanks, Steve, for the introduction.
I'll turn.
Yeah, thank you so much. Cool. All right, so today I'm talking about data foundations for an agentic world, but it's maybe not all as encompassing as the previous presentations you heard of today. So without further ado, I just want to give you some takeaways that I want you to get from this talk. Basically, I just want to go over, how we configured our OpenMetadata setup, how we did user outreach, what we really treated as our first product when starting to roll this out, and just kind of how to use the platform a bit better as agents are becoming more prolific in the workplace. Cool. So with that, my story starts at the search for proper data. As Steve alluded to, I used to be a data scientist, so I'll just walk you through what my career looked like. I graduated with a bachelor's in statistics. Shortly after, I got my first job. I was a data analyst, and so that entailed a lot of data consumption. Curiously enough, we didn't even have a data catalog at this first job, so I already kind of knew where the pain points were. But then I also ended up joining Yelp shortly thereafter. And that's really where I guess the motivating problem for me started. So as an end user, I join, I get a question, hey, can you tell us what the ideal customer profile is for our product's clients, right? So I would go type in a search, right? Product, hopefully I get the proper thing at the top of my search. But unfortunately, what happened is our data catalog had a lot of duplicates. A bit of the reasoning why is because we have things in Athena. Spectrum shares that to Redshift. You end up having a duplicate on all of your different Redshift clusters. And so it means you get a lot of the same thing. And maybe only one of these is documented, or worse, none of them are. As sometimes it was, I would have some placeholder docs that we had rolled over. There's no documentation, and it was just really hard to know what I should be using, right? So really what the data catalog had suffered from at that point in time was just trust decay, right? I'm not sure what I should go use, even how to search for things to get good search relevance, right? On top of that, we had lacking documentation, and it's not just for a lack of wanting. It's the problem was we had limited write licenses because of our agreement with our vendor. So you can kind of expect this to be very detrimental to the quality of documentation, and compound this with a lot of duplication. It just made it really hard to get good answers out of my data catalog. And so, continuing this on, after a few years working on the data science team, I ended up switching to work on data platforms. So I became a software engineer or data platform engineer, however you see it. And really, that's when I joined the analytics engineering team. Now my team does a lot of cool stuff, but just a few things off the top. We manage a multi-project DPT ecosystem. That meant encoding a lot of best practices in terms of documentation. So we had really good, rich documentation just coming out of this, but it's only a fraction of the data we had, right? And top of that, we manage our data quality and monitoring platform. We have data catalog and lineage nowadays that is like a lot more prolific with OpenMetadata. We also host a report delivery platform which powers our sales teams. And then on top of that, we have our analytics handbook, which is a great source of context for teams to learn how to use kind of all of our platforms, but it's also great for agents now that they can digest all of our best practices there. And so for us, what the opportunity really was is to apply a product mindset, right? For me, my personal story started at search. And so I'll just hop into how search is top of funnel. I'm kind of assuming a lot of things, like you have data, you have documentation, you have ownership, a bunch of things. But for us, the last mile was one of the biggest points of friction. And so I ended up hitting a search. I would land into the discovery stage and having to evaluate where and what to pick. And I really just got stuck at that first step of discovering what was even relevant. Compound that with organizations where maybe you acquire a company, you inherit its data model, but then your new name for your product doesn't map strictly onto it. Makes it very hard to go and find data appropriately. And utilization is really where the value is in companies. Helping your stakeholders, especially in product, make decisions is really where we want to be. And so if I had a dream product, for me, my experience should have been, I come here, right? I don't have this duplicative search. I have kind of the first thing at the top. Of course, it's a very idealistic view, but it should be very clear to me what I should be using, right? And then I go here, You can kind of see a little mock-up of how it looks on OpenMetadata, but I would have my search page logs. I'd have a bunch of column names and descriptions. I might have links to external documentation because you don't want to blow up your context all the time in terms of descriptions. And I have a bunch of different things like, what's the DBT code underlying it? That makes it very digestible for even non-DBT users to kind of digest what's going on. And so that kind of brought us to a thesis that, the foundation of data discovery is good search. I guess on top of this, just one thing, by encoding priorities inside of your search, like documentation quality, usage, a bunch of things, are kind of incentivizing the data community to kind of follow your best practices to make things more visible. And so, having search is like quite a great way to instill some incentives there. I'll just go real quick over why we picked OpenMetadata. We had looked at prior vendors, but we didn't end up going with them just because of a lot of dependencies. But for us, the great thing about OpenMetadata is, again, the focus on search over here. You can kind of see how it looks inside of OpenMetadata in terms of customizing your algorithms. But on top of that, just the fact that the API support was broad and accessible, right? I can have my developers go and get their own access key that's scoped to their permissions, and they don't really go past what they're allowed to see or manipulate. And then on top of that, it's open source and extensible. And I really have to give credit to two teams in Yelp, ML Compute and Streamhouse. They did really great contributions on the open lineage front, for our Spark pipelines and getting that all labeled and indexed properly. And that was how we ended up contributing to OpenMetadata on top of a few search optimizations, right? The payloads were quite big, too much context, bit slow. So we ended up also pushing some fixes there. And so, yeah, this is really just a problem of bringing our own search algorithm. And so just some context as to why we needed this. We have a lot of things. Search is very critical when you have many things. The importance of search scales quite quickly with how many more assets you have indexed. We have keyword search, which is great. And now there's hybrid search with the semantic search and open metadata, but it doesn't weigh things like your trust signals. So whether there's a lot of usage, tiering, certifications, and whatnot, we also wanted to provide a persona-centric experience. So basically, you can apply policies and kind of hide things from people. I'll go into that later. Also, be able to link to what your canonical source is rather than say, here's the 3 duplicates. You can basically bring the canonical one up top, kind of represent the other ones, the duplicates in the lineage. But that's another reason. And then, finally, just because agents, sometimes they might give up a bit quickly on search. And so you want to give them great results upfront. And so that involved building what we call a search management system. It helped us do fast iterations because sometimes having to do the API calls on the front end was a bit tough for us. Again, that kind of involved better responsiveness. Please forgive the visibility of slides, but you can kind of see we have a score decomposition just to interpret how we shift the algorithm and how that impacts things downstream. We have checkpointing and versioning that lets us kind of save what our ideal algorithm is at one point in time and come back to it should we ruin any experiences into the future. But just to avoid that, we also have evals to make sure that, hey, just to get a read on things, what tables would I expect for certain search terms, and do those actually get raised up to the top 5, top N in my evals. And so just going into kind of using policies and tags, I'm just going to go through this quick. Our data consumers don't really care about what underlies their data. They just want to see what is accessible to them. So what we ended up doing is applying policies, limiting visibility to things that are very irrelevant to who you consider to be a typical analyst. And so basically here, what's visible is all the tables they have access to. But on top of that, we'd hide things like Kafka topics, Flink, the open lineage entities. And one cool thing is you'll still see these in the lineage. You won't click into them really, but it still gives you much of a quite a good look at how stuff flows end to end. And if you're a data engineer or just engineer in general, we don't filter anything. I think you're quite well versed enough to go and use the filters on your own terms, and many more things are relevant to you. So I guess I'll just pivot into how we view search for agents here, right? Because they don't search like humans. There's a lot of business context, we've talked about through the whole conference. They don't have the context to really make the proper searches. Oftentimes they'll make leaps in judgment and try to be hasty with how they answer questions. Sometimes they'll search with a lot of keywords. And if you've used keyword search, maybe more than 5 keywords can kind of yield very few results, which can kind of trick the agent into assuming, hey, no data exists for my search term, right? And even though you might prompt them so, they'll still go and add many more keywords than really needed. And I guess finally, the biggest thing for us is that agents are vulnerable to context explosions. In DBT, we had very rich context, but at the same time, more tokens kind of get chewed through in the discovery process. And, without having to go to like 1 million context window, which incurs a lot more cost, we want to be able to control that. And then finally, there's guidelines you need for agents, mostly skills to kind of encode how they should use the MCP. I'll kind of go into that in the next slide. So for us, we had a requirement of just centralizing this so people can use the regular credentials to be able to access it. We needed our MCP to be read-only, which sounds a bit like contrarian because a lot of people are using stuff to kind of enrich the data catalog. But for us, the fact it's centralized means it had to be read-only. Might get fixed with user impersonation, but we wanted to give a CLI for pushing docs, giving more of a Terraform plan apply. If you've ever tried to play with that, that gives you the diffs that would actually be done onto your assets. And on top of that, we need to have token efficiency. So here you can see we have a token benchmark just to see how different granularities. Here we have list, skim, peek, dive. So agents can go like, just do a search, get a read on things. And if they really need to go and get more detail, they can get the entity with different levels of verbosities. And so that's pretty much one of the ways that we try to limit tokens and give a set of things you can see. But we also give the flexibility of kind of searching given, searching certain things you might want. Maybe you only care about the columns. And so just to show you, this is how our MCP currently looks. Actually, I think a few things changed since then, but we're only at around 7 tools. If you tried the OpenMetadata one, there's about 11 tools. And so for us, it's really about reducing the confusion about what to pick and just getting better activation of what should be used, kind of like Bonnie had highlighted with regards to keeping tool availables a bit lower. What that meant is we also had token economy because we get to kind of craft our own doc string. For us, a lot of the search kind of methodology goes into the skills, not really the doc string, because every time you load your skill or your tool, you have to read the doc string and it can add up really quickly. We also wanted to reduce, the parameters that are available. And so we still provide a lot of the things like query filters, but instead of requiring like a huge JSON blob that the agent might kind of struggle to do, we just give it kind of a JSON that is kind of mapped onto things that might be relevant, service type, table types, etc. And so I just want to give you a few learnings that we've had through working through all this. We're still kind of scaling our use of agents because we want to do it a bit carefully. But, it's very pervasive at Yelp, and we want to give people, different flows that are flexible as to how they use things, if they use Codex or Claude or Cursor. And so for us, oh, wow, I only have 1 minute. Apologies. So I guess I'll just skip through this. There's a lot of learnings, but you want a strict discovery flow. I'll go through our milestones real quickly. Took us a while to survey the data catalogs and go through our alpha, give our upstream contributions, and have partnerships. But I'll just go through the takeaways. And so we did so much more than search. I could enumerate so much, but we have certification processes that kind of have a checklist of things you need to get to the next level. That way people can actually kind of follow those incentives we guided them to. We have so many more things. User consultations is probably the biggest one. And so with that, I want to kind of show you how the platform teams actualize, right? You equip, you enable your data practitioners. They help you improve your platform, and that's how you help the business. And so with that, I'll just close with this. Data catalogs are really not a panacea. I've assumed a lot of things around data culture here. Documentation, do you even have it? That people have ownership, that's very clear. But that's your immediate priority. Then you want to encode what standards you expect, data quality-wise. And then you want to sustain your adoption, helping people contribute a bit more documentation-wise, and just utilize the data with agents. And so, yeah, that's my talk. Hopefully you enjoyed it.
It was awesome. Amy, thank you so much. You've got a lot to share here, and I just want to thank you for taking the time to present all this. We'd love to have you back for another Open Metadata Community Spotlight if you'd like to dig into some other areas. We didn't mean to rush you at the end, but Thank you very much for your contributions to the community as well. So we really appreciate everything you've done with and for the Open Metadata community.
Cool. Thank you so much, Steve.
All right. We'll talk soon. Thank you. That was amazing. Very cool. So next up, we're going to go into a panel discussion. But before we do that, I love panel or polling questions. So we're going to do that as well. So yeah, let's just go straight to the polling question before we bring the experts on to the governance panel. So poll number 3 will actually set up some of the conversation that we're going to have in the panel discussion around governance. So how are you governing AI and data today? You saw Harsha speak a little bit about some of the things coming in Collate to help govern not only the data, but the AI models themselves. So the options that you have on the right-hand side of your screen should be option A, manual processes and policies. I've worked in this space for a while. I've seen people manage their governance in spreadsheets and Word documents, model cards that are 25 pages long. That happens. Option B would be some level of automation and the tooling, but still manual documentation versus governance using, let's say, a proper software tool that has some level of automation, policy controls, access controls, being able to tag what data applies to PII or not, et cetera. And then option D could be having no formal approach at all. So if you could please just take a moment to fill that out. Let me see if I can find it on my own screen over here. Polls, option number 3, poll 3, poll 2. All right. Cool. So if you submit a response, you'll be able to see everyone else's responses. And yeah, so we look and we see we have 46% of you have some level of automation, but still a lot of manual documentation. That's not surprising. It's very common from what I've seen. Number 2, well, tied for number 2 is manual processes and policies only, or having no formal approach at all, followed by fully automated, largely automated, about 14% of you. So still work to be done in that area. I know governance isn't always the most fun part of data analytics, but it certainly is something that is important when it comes to regulatory compliance. And so speaking of that, let's get on to the panel itself. So thanks again for giving those insights on the polls. Next, I'd like to introduce our panelists and then bring them on stage. So first, we will be welcoming back Angelita Frozza Sanchez, the head of platform engineering from Scout24. We will also have Lucas Potsky, an analytics solution architect at Airbus, who specializes in AI, large-scale analytics solutions, and data governance, while with experience driving data infrastructure integration and digital transformation across the aerospace industry. And I'm also delighted to have Dan Kostecki from Ambry Genetics, who is in the data engineering and operations group, where he develops and enhances ingestion mechanisms and transformation processes for multimodal clinical data within Ambry's internal data warehouse and application suite. That is not easy to narrate. He does a lot of great things and has a background in biotech and chemical engineering, which is near and dear to my heart. So please welcome our panelists onto the stage, and we'll get started here with yours truly doing a little bit of hosting. Lucas, great to see you. How are you today?
Hi, great to be here. Thanks.
Awesome. Dan, I love the background, looking good. And Angelita,
Hi.
good to see you again. Awesome. So we've already done some introductions, but would love to get sort of a one-sentence update from each of you. You can take my slides down. We're just going to have a conversation. If that's, I guess I can stop screen sharing. See if that works. All right, there we go. Now we can see everybody. So let's start off with kind of one sentence on the most interesting data challenge you're dealing with right now. Let's start with Dan, since you're to the right of me, at least on my screen. What's the number one thing in one sentence that you're dealing with right now from a governance perspective?
Right this second, probably a longitudinal hereditary cancer testing study that's about 2 decades worth of, like, it's 20 plus years of research data. So yeah, right this second, that's probably the most challenging governance related item I'm working on. It's for a third-party research collaboration, but yeah, just the data volume, number of patient samples to effectively collate see what I did there, and transmit eventually to this research consortium, just due to the data volume and associated like variant level attributes that need to be displayed. So
amazing. That sounds, I mean, it does sound exciting, really interesting too, from a cancer research perspective. Very cool. Angelita, over to you. What's the one thing you're focused on right now, in a sentence, if you could, on data governance that's sort of keeping you up at night or is front and center for you?
Getting better context to AI. Simple like this. I think this is the challenge of the moment.
Yeah, that is the hot topic these days around the AI world. Lucas, same for you, and it's totally fine to keep it at the trend level. I know you can't get into Airbus specifics, but from a governance challenge perspective, what are some of the things or one of the top things you're thinking about holistically?
I mean, one of the biggest thing is the increasing demand for real-time data and how we can integrate that into IA automation. This is one of the most interesting thing that's going on right now.
Real-time data. Yep. There's different definitions of that we've seen float around, but with Kafka and everything else, it's more real-time than in the past. Awesome. Okay, so let's dive a little bit more into governing for agents. This panel is about governing in the world of AI, where agents are becoming bigger consumers of data over humans. So I'd like to have all three of you give a perspective, but we'll start with Angelita. So when an AI agent becomes your primary consumer, what's the first thing that breaks in your existing governance model, or what assumptions turned out to be wrong or different when you started to think about agents coming to your context layer?
Yeah, I think that the first thing that breaks is the assumption that the documentation that worked for humans as context to take decisions would work also for agents. This is not true. If you start with this assumption, you will have bad answers, but very well written and very well formatted. And then there is a high tendency that people trust because it's beautiful. Right. So, and because of this, you need to make the outcomes of AI transparent. I think this is what I have in my mind at the moment.
I see. Yeah, transparency is important. Lucas, from your perspective, what changes when you start to think about agents accessing data within an organization?
I absolutely agree with Angelita that high quality context is absolutely critical. I mean, think of an agent as a new employee that's onboarded today. And is your data ecosystem, your quality, your documentation solid enough for a human to make decisions on day one after looking at it? Or are you overly relying on knowledge that is still somewhere in people's heads? That is then the crucial part of knowledge that makes a decision right. And how can you trust an agent making decisions without that knowledge? So you need to somehow pull it out of the head of your employees.
So it's probably more work to start as you start to onboard these agents to make sure everything's tuned for a brand new employee. I like the way you frame that. Awesome. Yep. Okay, Dan, anything from your perspective that sort of needs to shift and is different from a governance perspective when AI agents are becoming your consumer?
I just emphasize what Angelita and Lucas already said, like the quality of the training set itself, especially for biological data, like cannot be overstated. You need to emphasize the quality of whatever agentic representation you're trying to run on true clinical data from patient samples. So naturally, like governing principles like PHI exclusion, treating research use only data as research use is essential. All that feeds into the model and improves results when AI agents are operating on like variant level data from real patient samples.
Awesome. All right, Dan, let's stay with you. You're, as you just described, working with highly sensitive clinical data, and you are part of a merger, which I know you can't get into a lot of the details around Tempus and Ambry Genetics coming together. But when you started thinking about how AI agents could query that data, is there a specific or the first governance question you had to answer, and how did you answer that?
Yeah, it's a wonderful question because just as you said, Ambry historically was nowhere near the level of, I guess, AI maturity or as evolved as Tempest AI was prior to the acquisition. So internally, we'd done sort of AI like 4As with commercially available tools like variant effect predictors, Splice AI, sort of, like biologically accessible for research type AI agents. But now with additional Tempest input and Tempest resources, it's very cool to see where we can go with our host of internal data and expose it to like the level of AI maturity that Tempest provides. And all this kind of ties into how do we govern data between both companies, which you'll hear more about at the lightning talk. But yeah, wonderful question. And I just say it's sort of reconciliation of two different clinical diagnostics organizations and sort of comparing the level of AI maturity between both.
And you got twice as many resources once the companies came together, right?
Exactly.
Awesome. Okay. Let's shift. I know when we talked a couple of weeks ago preparing for this panel, there was just a lot of interest and discussion around regulatory requirements in different regions, different countries, et cetera, and it's getting even crazier now with the EU AI Act and things like that. So maybe if we could start with Lucas from a global perspective. When you think about large organizations in the aerospace industry, how do you think about the different rules and how does that differ by region? And, if you could sort of give a little bit of color of what you see across your regions and more broadly in the EU between GDPR, the EU AI Act, et cetera. Does each force you to design differently, or do you think of these holistically? Are there similar overlaps? Like, how much complexity does that add and how do you deal with that?
Yeah, sure. So regulatory constraints exist on so many levels, especially in the EU and especially in Germany then again. So GDPR and the EU AI Act are likely the best known of them. And they, of course, have to be an integral part of everything that we do, starting with creating awareness through solid trainings and apply them in every step from the idea to deployments of solutions. And in Germany specifically, there are then another strict boundaries on tracking productivity of your own employees. And this is oversight and subject to approval of works councils that are then elected by employees. So any kind of data that could, in theory, be used to measure performance, if you want to use this data for any purpose, you require prior approval before you start doing that. And then, of course, in our globalized world, creating additional challenges around data locality. So moving data across countries might be restricted either by GDPR or export control regulations. And especially with large language models being mostly in the cloud somewhere, you're always transferring data. And you really have to think about what you're doing beforehand. And now I've not even touched the industry-specific regulations in aerospace, for example, certification, which then it's a whole other level of complexity and thing that you have to think about, especially with non-deterministic AI. So overall, this always needs to be viewed in context, and you have to have a clear understanding what data asset is classified. And you need some kind of centralized approach in a data catalog to do that, especially when moving data between platforms. Having the ability to classify its source and then propagate that to downstream usage is absolutely critical and has to somehow stay on top of all these regulations.
Yeah, and Angelita is also in Germany, ironically. Is anything that you would add, Angelita, from your perspective? A very different type of business than aerospace. Is there
but I would say we share the basic regulations, GDPR, EU AI Act, also the protection to the employees. You can imagine that you can use the number of messages that someone wrote on Slack as a way to measure employee performance, right? If you expand this thought, it applies for basically everything. Every MCP that you have nowadays would allow you to track an employee. But on our industry, as you might have seen on one of our child companies, we have companies that are BaFin regulated, which adds another layer on top, which is the central bank regulations. So on top of the standard regulations for the region, we also have the central bank regulations that we are subject to. And all of this, as Lucas wisely said, adds a layer that this thought needs to start when you are designing your application. Let's talk like this. You need to think on how you comply with all of this, starting on the design.
That is a lot of complexity. And speaking of that, Dan, you've got some of your own additional regulations that you deal with in the US around HIPAA, FDA 21. I can't even read off all the acronyms of the things that I've seen you talk about. Can you give a little bit of color of how you work through that?
Yeah, absolutely. And I empathize with sort of the, not maze, but levels of regulatory hierarchy. Because just like Lucas and Angelita have been saying, we have, very specific state, local, and federal requirements for safe handling of patient-derived genetic data. So information, PHI statutes, FDA regulations at the federal level, EHR and medical record storage compliance that we need to be able to provide evidence of, in addition to lab-specific requirements like CAP and CLIA accreditation. I can't overstate the need to document and be able to prove that all of these regulations are being adhered to the letter before any kind of analysis or data sharing can occur with patient-derived genetic data. So yeah, it's a lot to deal with. But Collate and the clinical data product concept is making this much easier for all parties involved, as we've discovered. So
awesome. Looking forward to your talk about that later.
Oh, thanks.
And I'm just curious, do you have, how frequently will an auditor or somebody outside of your own organization ask to see documentation on things like this?
Yeah, it's a great question. We're, audit prepared, I think, at all times when regulatory or inspections for audit related stuff or compliance related ask comes along. It's essential to be able to provide data and sort of the traceability of whatever you're being audited for. Again, this is where we want to take our Collate install to be able to provide evidence of those regulatory compliance for all clinical data products that are checked into Collate. So Collate's definitely making things easier, but it's just a web of regulatory aspects that need to be defined, cataloged, and made visible within the application.
Got it. Thanks for that additional detail. Cool. So that's a great perspective on agents as consumers and all the regulatory things you're dealing with. Maybe if we could shift a little bit to talk about what's working well in production or where you're having challenges. And so, Angelita, a question for you. You talked about a model where data classification is in one layer and being propagated downstream to control not only what the people, but the agents can access. Can you describe a little bit more about that process and how that works? And are there still gaps in that process, or is everything ironed out and it's the one and done kind of thing that you have those classification and access controls put in place?
Unfortunately, it's never fully done, or fortunately, because we always have space to make things better and different. So in our case, we had already data contracts predefined on the YAML files. Then we didn't want to lose all of this. Then we imported all of this inside Collate. And then we share the same classification, but also we have an enrichment process on Collate per se for the fields that were not classified. We can still enrich with additional layer. And from there, we propagate for our query engines, because when the person authenticate on the agent, on the internal data agent, for example, someone asks, tell me which customer made certain action on the website yesterday. The first thing that we will do, we will authenticate this person, understand which type of permissions this person have, and if this person has the right to access PII information or not. And then when we reach Collate, or when we reach the SQL engine, those records would be anonymized for the person that doesn't have the legal right. So we have a central place where we propagate for internal data agents the PII classification. Then we know where to look on to enrich the process. Because this is one problem. When you have several different places doing the same thing, where do you improve, right? So even if the classification per se resides outside Collate, we put everything on Collate, and there is like our control panel, talking in Lucas' vocabulary. It's our control panel to see where we are flying to.
Okay, that's great insight. I'm going to go a little bit out of our questions. I saw one pop up in the Q&A chat, which is actually tied back a little bit to the previous topic. And Jason's asking how closely people are working with their legal teams or DPOs, which I assume is data privacy officers, to make sure AI agents aren't doing things with data that they shouldn't be, such as shadow agent usage, et cetera. Do any of you have a perspective on that? Are you working with legal teams and DPOs on a regular within your organizations? Lots of heads nodding.
Very frequently. I mean, our compliance and legal department was instrumental in sort of laying the groundwork for our PHI classification tags, kind of as Angelita alluded to. We maintain a similar collection of PHI elements for which, you know, we apply these elements to collate metadata jobs. And yeah, compliance, legal, and regulatory all provided those PHI definitions, and that greatly assisted with like initial setup and like collate automations for known PII elements that came from regulatory. Great question.
Cool. Anything Lucas or Angelita want to add on that one?
Yeah, me too. So I'm basically co-owning the data catalog and all the classification with the data governance manager and also data privacy officers. So there's, of course, a deep connection. It has to be that way.
Yeah.
Yeah, on my case also, our DPO made data protection coordinators network. So we have people in each department that went through education process to become a data protector coordinator. And every agent, for example, we need to document as a data processing entity, because the agents will process data, then we have to document and share this with the DPO. Each agent has its own documentation, which data it receives, for which purpose, and so on.
Got it. Awesome. Thanks for handling that ad hoc question. All right, so Dan, over to you. There's a question about governance and your world expanding. We talked a little bit about the merger, where you've got two organizations with many similar clinical concepts that businesses, I'm sure, are slightly different, but completely definitions perhaps on some of the similar terms. So before we get into how it works, if you could take us back, like how did you do that before having a system like Collate? If you could walk us through what a single data request would look like and what you had to go through to fulfill that. And you can keep it on the technical side. You know, you don't need to get into any M&A type of stuff, but you know, yeah, what was life before you started to automate some of these access requests and the governance that's required around that?
Pretty involved. It depends on the data request, like the originating party, and also whether it's intended, you know, for commercial or for research use. But prior to Collate, like a typical data product ask would involve, you know, a stop by bioinformatics to collect like pipeline output and necessary file types for like your patient cohort of interest. Like you would have to collect VCF, spam file, FASTQ files, etc., and then separately look up like relevant order level information, and then, you know, assay or clinical product and procedure information that was also associated with the same case. Like it was a pretty manual process, collecting all these files, expunging PHI, essentially preparing this package of biological and commercial information that constitutes like a case for external use or for sharing. But yeah, as you said, Collate is definitely making this easier, because it's quite easy to tell whether or not your derived data product has any PHI elements, because all the metadata is already in Collate. But yeah, prior to Collate, it was very time consuming, a lot of manual steps to gather files, Sort of ad hoc SQL queries as necessary to look up relevant information that would need to be written for the requesting entity. But life is getting much easier with the clinical data product concept and open metadata assistance, I would say. It's a great question.
Very cool. Very cool. So, I mean, what's it like when you've got perhaps different definitions of similar concepts from a governance perspective? Do you need to resolve that ambiguity, or do you have like a fuzzy matching or some way to handle that more automated? Can you give us a little bit of color on that? And also then, like, how do you make sure that's in place for an agent that may not be able to know they need to phone a friend at your sister company to sort things out?
Yeah, it's a great question too, especially timing wise, because prior to the Tempest acquisition, we had an idea of data governance specifically tailored for Ambry with, stewards roles and sort of a governance council in mind. And now that we're partnered with Tempest, we're kind of in that evaluate the Venn diagram overlap part of the data governance question, where we're trying to, just as you said, identify sort of common language or common themes for governance between both organizations, and then unify those in like an Ambry Tempest Data Governance Council, and then further define roles, apply agents, to the governed principles after like they're mutually decided upon.
Very cool. All right. Cool. Lucas, let's shift over. I know we had talked about data as a product, and Dan was mentioning clinical data products. And this is a pretty complicated two-part question, but again, I've been in this industry for a while as well, and there's been this ongoing debate about how much do you centralize governance versus decentralize that? What's owned by the platform team from a central perspective versus having to distribute it across the business owners? So part one is, where are you seeing in your experience, now or in the past, where large organizations are landing on this? And does that answer change when AI governance enters the pictures and you have agents, in terms of decentralization versus federation, if you will, of policy controls and governance and access to the data and that sort of thing?
Yeah, great question. And the big question, I think in the end, you will always move to some kind of hybrid model. You will need some central platform teams that owns infrastructure, global policies, standard tooling, automation around it. However, the actual data products must be owned by domains, and the classification, the data definitions must be owned by the business domain that is as close as possible to what actually happens in the real world, simply because they better understand the business context. And AI, in the end, doesn't really change a lot. It just accelerates this need. So a central team cannot possibly keep up with the unique needs and everything that's changed in the speed that we need to deploy artificial intelligence. So yes, central teams need to provide guardrails. They need to make sure that all the domains speak a common language and interconnect with each other, because you don't want to create silos. That's the other side of the coin. But you need to have some kind of level of freedom while still make sure that the technology is same, and you'll have some kind of connection, semantic connection between the different business domains.
I see. And with delivering data as a product and creating those curated assets and having a domain owner that comes from the business, does that make it easier or more complicated for the centralized IT team, or
it is
what's
definitely
the impact, I guess, of that?
Yes, it is definitely complicated, but you don't have an alternative. So what do you do? You have to have governance. You can't have chaos. So yes, the upfront work is definitely harder. The hardest part, in my experience, is setting up the organization that actually is able to support true ownership of data, not just on paper, but actually live the responsibility that comes with owning data. That's the hard part, and I haven't found the shortcut personally yet. And the AI agent in the end is also just a defined consumer that relies the same way on clean and trusted data. And if you just accelerate your decision making with bad data, you also accelerate making the same bad decisions as human have been done in the past. You're just making them faster and much more of them. So you haven't really won anything.
Got it. So there is no choice. Data products are the answer. Governance in place for everyone, including the agents, even more so. Awesome. Okay, so let's talk a little bit about what's next. So if you were designing your governance program from scratch today, knowing what you know now in terms of being able, you have to plan for these unruly agents that don't follow rules sometimes, and you can't really fire them. But with that from day one, is there one thing that you would do differently? I'll kind of go from left to right on my screen here. Dan, anything that you would do differently, knowing what you know now?
I think establishing the governing body, like the associated roles, personas, and sort of getting like your data governance entity together with respect to personnel would have saved a lot of time, at least for my totally biased experience from like the early days of Ambry data governance discussions. But it's a lot easier to sort of scope out the governance vision for the organization if you have roles, personas, and users in mind, especially with respect to data stewards kind of per business unit, because we found that it's extremely helpful to have a specialized data steward for, variant assessment or for the reporting team, able to sort of consolidate the wants and needs and data governance like requirements for that business unit and like feed it up the chain to the overarching like data governance organization. So I just emphasize like the personal aspect of it and establishing like the roles from the start.
Very good point. Very good point. Lucas, what's your perspective on that? What would you change?
I agree with Dan, and I'll have to add that making semantic layers and data lineage machine readable from day one is pretty much the one that I would pick, because of course you'll somehow need something that is human readable still, but with agents having everything in plain text, ideally, rules for machine readability. So that's one I would change.
Got it. Machine readable from day one. Anything, Angelita, from day one that you would do differently?
I will take those that was said before, and I will add one more. And I would technically reinforce as much governance as I can where it's key, because there is a lot of old practices where you have governance on paper but not technically reinforced. And I always say that, or you technically reinforce or you accept the chaos, because then each person will do as they interpret. So technical reinforcement of governance is key. And in the agents era, it's even more important.
Very good perspective. Yeah. And so sort of an ad hoc question, when it comes to establishing the governance body and getting these people to, let's say, document and things like that, how do you achieve that? Does it need to be a top-down mandate? Is it CEO level? What level of encouragement do you need, or are people within the organization typically very helpful on some of these things when you start to think about getting governance put in place? Maybe Dan, since you had brought that up, what's your point of view on that? If somebody needs to establish that governance body, who needs to drive that?
Yeah, that's a great question. Again, from my Ambry experience, we sort of identified data governance council members just from the requesting departments that were known to have data that need to be governed. So we'd have volunteers from the accessioning department or from billing or from commercial operations wanting to contribute and govern their particular aspect of the business. And that sort of enthusiasm carried over to, managers and directors. And I think that, advocacy for data governance for a particular business unit kind of became the basis for formation of the Data Governance Council. So kind of a long-winded way of saying it originates with the need for data governance for specific reasons within a business unit. Then supervisors, directors are notified, other directors begin to talk about it and say, hey, we have a compelling need to govern this same piece of data or process or workflow due to reasons X, Y, and Z. And those reasons and motivations kind of became the basis for the Data Governance Council at Ambry anyway. So.
Okay, got it. All right, so if someone in the audience is about to let their first AI agent access production data next week, what's the one alarm bell or the one thing you would say you've got to get in place before they flip that switch? Lucas, maybe we'll start with you. Is it machine readable data or something else?
I mean, I'd say make sure that you know which decisions your agent took, and make it clear to all the humans involved in that that it was an agent that took the decision, and that they understand what implications that has. That they need to have some kind of training to gain the knowledge to correctly judge the output is the most crucial thing, I believe.
And being able to document all the log files, if you will, of the agent and what decisions they're making, so you can audit that.
Yeah, and if you somewhere surface the result of an agent, it needs to be clear that that's an agent that's talking to you and not something a human produced.
Got it. All right, Angelita, over to you. What's the one piece of advice you would have to somebody before they flip the switch on agents going after production data?
I would insist on transparency on top of everything that Lucas said. I think that nowadays people are more resilient to not have 100% accurate answers, but they are not as resilient to have false positives that they don't know, right? And then it just disrupts trust. And once the trust is disrupted, it's very difficult to get it back. So start with transparency from the day one. If your answer is not good, show that's not good, look for a human, and then you improve on top of that.
Yeah, trust is paramount. Dan, what's your perspective?
Emphasizing what Angelita and Lucas have already said, transparency is, in my opinion, like selling factor number one. You need to be able to see the decisions the agent made on production data, have that output log somewhere, and sort of be able to see every step of the process or the operations that were taken on your production data set. So
yeah, makes sense. Awesome. Well, that does it. So we're going to take a break here, but I just want to thank you each for taking the time to join us today to share your knowledge with the rest of the audience. Hopefully everybody got a lot out of it. I really enjoyed the discussion. So Dan, Lucas, Angelita, thank you so much for joining us today. We're going to take a quick break and then we'll be back after that. So thank you.
Thank you.
So we've shifted from the panel discussions. If you could pull my slides back up, should be there. All right. Very good. So, I love polls. This is the 4th out of 5 polls, and then we'll do a quick overview of how we're going to work with the breakout tracks, and then we'll take a quick bio break. You can grab a drink. So poll number 4 is live. What does your data agent or your AI agent know about your data when it answers a question? Is it just getting the schema and maybe some table and column names? Do you have a schema plus some level of documentation, perhaps in a data catalog? What other types of metadata, lineage, business loss returns? How far are you going with giving all this context to your agents? So options D and E, you can kind of see them all there. I'm going to see if I can do this poll myself. So let's see, poll number 4, there you are. And then maybe some of you are not connecting agents to data context yet at all. So let's see what we've got, people coming in. So it looks like most folks, well, 30% are schema plus some documentation, 25% are all of the above plus relationships, ownership, and prior queries. Very good to see that. 20% or 21% have not connected agents to any type of data context yet. Anyway, so hopefully you all can see those results. So thanks for doing that. I want to tee up the next sections and then we'll kind of go to a quick break. So as I mentioned, we're going to break out into 2 tracks. I'm in track 1. So if you want to see what's coming in track 1, stay here. Track 2, you'll go onto stages, which is an icon on the left-hand side of your screen, and you'll be dropped into those. So let me, again, refresh on what the different tracks are. So these are the 2 tracks. Each of them will have product demos to start out. So we'll be going deeper into some of the things that you saw Harsha talk about earlier. So track 1, again, is context and governance. We'll have Mohit Yadav and Mayur Singhal from the Collate engineering team, who will demonstrate what AI for data teams looks like. And in that demo, they will follow a data engineer that's creating trusted data, high quality, with Collate AI, then a data steward who classifies critical tables, captures organizational memory, and defines a governed metric and ships an agent that automates PII review against those policies. So you'll see the open context layer, how it gets built and then distributed for humans and AI. So again, to watch track 1, you can stay here with me. In track 2, we're going to start things out with James Duen will be emceeing that track. We'll have Pere Miguel Bruhl, one of the Collate engineering founders, who will walk us through, together with Nick Doyle, a use case of putting that context to use from an AI analytics perspective. They'll walk through a fictitious example of a business analyst going to ask a question from a dashboard with Collate AI, and then the conversational memory making each teammate smarter, and then being able to showcase bringing context into external systems. Harsha will also be joining there to walk through some of the things he talked about earlier in a deeper dive. So showing AI governance capabilities within Collate 2.0 for visibility, governance, and auditability, which we just talked about in the panel, across your AI models, MCP servers, and agents. So again, to click track 2 or to get into track 2, click over on stages on the left-hand side, you'll see track 2, and you can go there. I'll be kicking things off here in track 1 around creating context, where we'll show you how data teams build the open context layer in Collate or OpenMetadata. And in this scenario, we'll be talking through Costbank, which is a large international retail bank, and their leadership team has a business initiative to drive improved customer lifetime value, or CLV, through better analysis and decision-making. So how do we do this? In this scenario, we have 2 people at Costbank tasked with answering just that. Meyer, who's an engineer, will be playing the role of a data engineer, and Mohit, an engineer at Collate, will play the role of a data steward. And together, they'll ensure the trust in data. They'll define what CLV means for Costbank, classify the data that powers it, and connect the policies that govern it. Without this foundation of a context layer, CLV and its data can mean different things to different teams, and no human analysis or AI agent built on top can really be trusted. Of note, we have a parallel product demo session happening right now where we're talking about consuming the context, where we cover the other side of that story in terms of how Costbank's analysts and CFO use the foundation we're about to build, all the way up through surfacing cross-sell revenue opportunities. So let's go ahead and get started with Meyer, who's opening Collate on a Monday morning at Costbank. Meyer, over to you.
Hi everyone, my name is Meyer. I'm a data engineer at Costbank, and my team owns customer lifetime value reporting and transaction monitoring. Like most days, I start mine in Collate to see what needs my attention. What you are seeing isn't a generic dashboard. Collate recognizes that I'm a data engineer and surface the action item I need to handle, approvals I owe to other team, and recommended cleanup and improvement. The first action looks important. I've got a data quality alert about a fraudulent transaction flag on closed account being treated as active. In traditional world, I would have to manually navigate to the data quality test, try to figure out what's wrong with it, and start a root cause analysis from scratch. Instead, I just click on the investigate and have Collate AI do the job for me. Collate AI already has a technical context it needs about our data. The table shape, the lineage, and the column profile. All of that comes from different agents Collate runs when the data is ingested into the platform. And when it comes to the queries, it runs it against my Redshift using my own credentials, not a shared service account. So the AI has the same access that my user has. As you can see, Collate AI is searching across platform to identify which assets are relevant. It's generating SQL queries based on what it's analyzing and executing them directly against Redshift. Bit by bit, it's building up the picture, which alerts are firing, which account they reference, and what are the actual state look like. The statuses it is surfacing, frozen, closed, and dormant, comes from the profiler agent that already scanned our data. So when Collate AI says these are the real account status, It's not guessing. There is the value of having real context in one place. The answers are based on data and are not hallucinated ones. Now I can see the details. Some of these alerts are flagging accounts that shouldn't be flagged. Dormant or closed accounts are being treated as active. I get the chart showing the alerts by timing, category, and severity. And I also get the list and the breakdown about the problematic account statuses. More importantly, Collate TI is giving me the root cause, the recommended fix, both the immediate fix and the source table level fixes. It's not abstract advice. It's tied to the tables I own. Root cause and the next steps are clear on that one. Let me take a look at the next action. Okay, so I can see there is a schema change that was introduced in our staging customers table. The data is continuously evolving. As we ship new features, table changes, columns are added, and we have to figure out what that means for our downstream systems. So using Collate AI, let's see what's the impact of this. Okay, we have the results. Thanks to Collate Metadata agent that regularly scans everything that's going on in the platform, I can see the changes that might otherwise go unnoticed. And by cross-referencing them through lineage, I can see exactly which intermediate tables and dim tables and dashboards might be impacted. We also have an interactive lineage available, so let's expand it. Using this lineage, I can figure out what to do next or which downstream teams needs to be informed to be looped in. We can also see the impact at column level as well. So this has got me covered. I've got my root causes and next steps for my morning. With this, I can ensure that our data is high quality and can be trusted. This is the foundation for trusted context to be used by human and AI data teams. Let me hand it over to Mohit, our data steward, who has the same Collate instance, but a totally different view because his job is totally different from mine.
Hi everyone, I am Mohit. I'm stepping into the role of data steward at Costbank. Mayur showed us how do we get data into Collate. Now we'll see how Collate AI helps turn that data into trusted context that the teams can actually use. We'll take a look at how governance, context, and shared knowledge come together to make data easier to understand and work with. Classification work and other items that are necessary for me to complete before our next audit. Everything is already prioritized based on my role. As part of the governance team, my job is to make sure data is trusted, governed, and ready for everyone across the business to use confidently. So the first thing I'm going to do is I'm going to promote DIM customers to the tier 1. So this DIM customers table powers our customer lifetime reporting. And based on our internal policy, I know that anything supporting critical reporting should be classified as business critical, which is tier 1. So I'm going to go ahead and say yes to this. Tier 1 isn't just a label. It carries business meaning with the asset itself, ownership, responsibilities, and the impact if something goes wrong. Collate AI suggested this classification based on how it understands this table is being used across Collate. So as you can see, this is Collate AI is searching for it, the DIM customers and DIM credit tables, and is going to go ahead and apply those tier to both of these tables. So once this table is promoted, Collate AI continues helping. That's our semantic layer at work. Business meaning flowing through the knowledge graph, not just technical relationship. As you can see, based on this dim customer asset, the Collate AI is also able to do a downstream impact analysis. What all other dashboards or tables or assets are impacted because of this dim customers table or dim credit risk table. So I can continue this conversation and work through these recommendations with the right owners, right? And I can go ahead based on this downstream impact. I can also inherit the tier 1 to these data assets. But for now, let's head to our homepage. Back on my landing page, here I see that there are some recommended improvements as well. So Collate AI is recommending that I promote this particular dim customer asset to a fully certified asset. So since it has an assigned owner, no failing DQ test, and a complete lineage, it is good to be promoted. So I can do the same process. I have reviewed it. I'm going to go ahead and just approve it. I'm going to say yes. All right, it is able to do so. So it has applied the gold certification on dim customers. And further, we know that this dim customers table has an owner, Alice, right? So Collate AI is smart enough to also send a notification to the Slack for Alice to let her know what has changed in the certification level. There is tier that got updated and gold certification that was applied to dim customers table. So tier classification is just one part of the governance. Let's go back to our home and see, before this scales across the bank, team also need to work from the same definition and business understanding. That's a bigger challenge we are going to solve in the next demo. Right, now since that is covered, the next thing we need to do is make sure the language across our organization is standardized. I'm going to start by searching the business glossary for customer lifetime value. Let me do that. Let me open it up. So this is a critical term. Every business analyst, every executive in this span is going to use it. If you do not have a canonical definition, retail is going to use one formula, wealth is going to use some other one. This is the problem of not having shared business semantics. You do not have a common understanding of what the data means. So in this case, as you can see, Collate is not able to find the glossary term for customer lifetime value. So instead of leaving that ambiguity in the organization, I'm going to create one glossary term. Let me do that. And I'm going to put it into the business customer glossary that we have. So based on my inputs, the Collate AI is proposing me the new term. So this looks good to me. I'm going to go ahead and create it. All right. So the term is created. I can see the summary. Now, another thing is we have human in the loop here as well. I use the Collate AI to help generate the definition. But before this definition becomes the official definition at Costbank, Alice or Mayur needs to review it and approve it. So that way we can use the Collate AI to create glossary terms which can have the shared knowledge across the organization. So now let's tackle another problem that we have. So there are things people often forget when running these calculations. One of those things is the churn risk adjustment. It is the kind of knowledge that usually lives in someone's head and never gets captured. So what I want to do is I want to attach this knowledge that I've created in the glossary term to a data asset, which is dim customers. So let me do that. I'm going to create a memory and attach it to dim customers. So it is creating the memory and attaching it to the dim customers. Okay, it completed that. Now, any future analysis by any analyst or AI workflow that touches dim customers automatically inherit this context. Now, if I go to the context center, I can see that memory that we created over here, and it is attached to the dim customers table. So the context center let us build the organization knowledge in multiple ways. We can have articles which are created within Collate that contain certain information that can be used by the Collate AI. we can also upload certain documents that gives us the context, the Collate AI, the context that is required, or the memories that we just saw. So before moving on, the last thing I want to do in the conversation is that I also want to do the calculation to be much more easier than this. I want to create a reusable metric for CL. So let me go ahead and do that. And I want to join it with some table that I know can be used for churn risk, and to also connect it with computed margins table that I know. All right, I'm going to go ahead and let it create the metric. So as you can see, Collate AI is doing all the analysis and the processing over here and coming up with the metric definition that we need. Very nice. So we have the query now. So this SQL it generates, it is not trivial. And that's exactly the point, right? Instead of every analyst rebuilding this slightly differently, what we're trying to do here is we are going to define it once and make it reusable across the organization, which is very important. You also get a detailed results of how this query looks like and what the table data is, right, based on those joins. So I can create that as a dashboard as well. So now the whole team is going to use the same calculations. The definitions, rules, metrics, everything is aligned. And that is what exactly turns data into something that the people can actually trust and use. Now, as we can see, once it is able to do so, we are able to create the metric. Based on that matrix, we can take a look at here. So we have the expression or the SQL that can be standardized and used by everyone, and the customer lifetime value metric that got created as well. And based on that metric, we are able to plot what are the 25 customers by adjusted customer lifetime value. And we can also view the data that it used and the query that it used to get that data. As we have seen so far, Collate AI feeds from the full knowledge graph and ontologies what we have built up in Collate. Technical metadata like schema, lineage, profiling, alongside business and organizational semantics in glossaries, metrics, and memories. In the example before, we created a memory, a piece of unstructured knowledge, and tied it to a table. The context center is where we can go even deeper. So let us take a look at the context center. In the context center, there are 3 ways to add organizational context here. First, we have articles. These can be links we want to bookmark or some unstructured data or content that we directly write inside Collate. Maybe a documentation on how a domain operates or guidance on naming convention. Second, we have documents. Documents could be PDFs, CSVs, text files, anything that we want to upload that contains the organizational knowledge that the Collate AI can use. The Collate AI is going to vectorize and parse this so it can reason over them when answering the questions or while running the automation. Then we have memories. Memories is what we just created for DIM customer. These are small facts, definitions, or user preferences captured by the teammates and attached to specific asset. Together with these 3 primitives, we make up the organizational context we control inside Collate. But here is the harder problem. Every governance team I have worked with has a runbook. Ours, our GDPR and PII handling policy at Costbank lives in Confluence and not really is in Collate. It can be a very long policy document, who can see what, how long we keep the data, and none of that lives in Collate today. I could copy that into Collate by uploading it as a document, but then that would take time to negotiate at the organization level and forever to keep both versions in sync. Or I can connect Confluence as a context source and let my agents read policy where it already lives. That is what makes this an open context layer, pulling knowledge from wherever it already lives instead of forcing everyone to move. So what we have is AI Studio. So I'm going with the second option. Let me head into the plugins. So you can see all the external connections that are supported by Collate. GitHub we have for code or PRs, Google Drive for storage purposes. We have Confluence as well, which is of my use currently. So if we want to use these plugins, what I need to do is I need to create some skill. Let me go ahead and do that. I can give it some name. Some description. And here I can select the plugin. The one that I need is the Confluence one. Based on the Confluence MCP server, we get a list of different tools that are being exposed. Like we can do page information searching, retrieving content, right? I want this skill to be able to fetch a specific page and also to be able to search using the Confluence query language. So I'm going to select these two tools and create the skill. Once that is done, I can build an agent around it. To build an agent, I need to go to agents and then create an agent. I'm going to name it. Let me add in description. And then as for the persona, I want it to behave as a data steward. Let me do that. So from here in the list of the tools, want to have the availabilities for the get Confluence page information and also for being able to search and discover the assets we have in the Collate. Now we can select the right board for this. I'm selecting the Collate AI application board for controlling the behavior of this agent. So once that is done, now I have a data steward agent that can read both Costbank's metadata and our own Confluence policies. Let me make my own life easier by wrapping it into an automation. Instead of coming in every morning and reviewing PII tagging by hand, I'll automate it. I can either pick from our automation templates or create one from scratch. So for now, I'm going to create one from scratch. Put some description. I'm going to have it run weekly, maybe 9. Further, I can also select the filtering criteria. For me, I wanted to apply this automation on tables, and I can further drill down based on the service. For us, this is the service and maybe the database schema. Go ahead and create this. Now this automation is created here. This is going to run every Monday at 9 a.m. The agent reads Costbank's GDPR policy from Confluence, applies it to our CLV tables, and flag any PII tagging that needs attention. PII tagging stops being something I do manually. It becomes something that the platform does for me. And I just review what the agent surfaces. Same way, I manage any other agents in my Collate instance. I can also manage this agent that we have just created. So that is all for the session from my end. What we have done is we have defined CLVs, classified our data, captured the memory rules, and connected our external policies. That is the open context layer at Costbank that brings together our metadata context, business semantics, and organizational memory. So it can be used by our human and AI data teams. So now further, our parallel session will cover how the rest of the bank, analysts, and executive teams use this foundation that we have built to further carry on.
Hello, everyone, and welcome to our product demo session. This is track 2, Consuming Context. We'll show you how data teams can use an open context layer from Collate for their work. Over in track 1, running in parallel, we'll cover how the context layer gets created. Now, in our demo scenario, we'll be working with Costbank, a large international banking institution. Their team has already built a context layer in Collate, so they've defined their customer lifetime value, or CLV, in their data and their glossary, built out memory rules, connected their PII policy. Now, Costbank wants to drive CLV growth with this context. So we'll walk through how this context shows up throughout the business, with everyone working through the same definitions and the same trusted source of truth. We'll start with Pare, a data analyst, as he breaks down CLV across different segments. Then Nick, the CFO, brings it into action, finding different cross-sell opportunities hidden in those segments. Mayor, the data engineer, brings that same context to Databricks for production ETL. Pare will then return to show how we can actually pull the same context into any application your team builds. And Harsha will show a demo for how this context can be used for not just governing your data, but also all your agents, LLMs, and AI assets. So let's get started with Pare.
Hey, I'm Pere, the data analyst, and I just got assigned a new ticket. I have to report how our customer lifetime value behaves across Costbank different segments. And I don't know what tables exist, I don't know what's certified, and I don't have access to half of them anyway. A few months ago, this would mean Slack threads, Confluence searches, a bunch of Jira tickets. Instead, today I can rely on Collate's data marketplace. I'm going to start by actually figuring out what's already there and ready to use. So, do we have any data products ready to use about customer retail data? Collate is going to use its hybrid search to give me the most relevant data products that have already been built and curated for anyone in the company to play with. From the available customer retail data products, looks like the Customer Accounts 360 is the most promising one. So let's try to get a few more details about it. Can you give me further details of the Customer Accounts data product? Awesome. In this case, I know the domain that it belongs to. I know its owners, Alice and Mayur. And I can see how the Customer Accounts data products contains some input and output ports, and a full list of curated assets that have some of the tables that might be useful for me in order to get my ticket done. In the traditional world, I would have to actually go and ping the data owners, open a ticket, and battle against other teams' priorities to try to get things done. Today, I can actually rely directly on Collate and its data marketplace features to open and get granted access to all of the data that I need in order to get my job done. Can you open a request for access to the Customer Accounts 360 data product? I need to analyze the customer lifetime value by segment for the leadership team. As you can see, we are still keeping the human in the loop, and I have to actually approve the request that it's going to be opened. In this case, since I have not specified anything, I'll be asking for full access to the data that's in there with my business justification, and the task will be automatically routed to the data product owner. So yes, let's get this moving. Great. So here in the right, I can see the task that was just open, the reason when it was opened, and I can jump straight into the data marketplace to actually go and dig in case that there's any other task that I have pending in there also to be reviewed and to be approved. I can check the details and I can directly follow up as part of the conversations in this task to try to estimate when this is going to land. Now that my data access request has been approved and the access granted at the data warehouse, we can start with the fun part. First thing that I have to do is to actually understand my customer lifetime value. So since I just got access to the data, I can directly rely on Collate AI and say, what does our customer base look like by customer lifetime value and broken out by segment? As always, Collate is going to start retrieving the Costbank's company knowledge, trying to figure out what existing data, terms, metrics, articles, whatever it is that we have in our knowledge graph that could help answer this question by routing the knowledge and semantics within our organization. Look at what just happened. The agent is actually going to use the customer lifetime value formula that our data stewards created before. This means that now I have the right canonical definition for customer lifetime value that's being used automatically by Collate. I didn't have to look up the formula. I didn't have to know which table holds the margin. It's just used the right definition because the platform knows the right definition. This is the big shift here, from people-ready data, where individuals have to tap into their tribal knowledge to fill in the gaps, to AI-ready data, where agents can navigate the knowledge graph, understand data nuances, and give us results rooted in a strong semantic foundation. The agent is able to discover tables, figure out the right joins, and get the proper filters going because it is not acting in isolation. Collate's metadata agents already retrieve the necessary profiling data, metrics, distributions, and samples, where a standalone agent would have to spend countless tokens and queries just to understand and discover the data. Collate directly taps into the knowledge graph to get things just right. While the execution happens, Collate is also giving me transparency on which are the SQL queries that are being executed. This means that I don't need to just blindly trust its choices or eat the results that are being sent back at me, because I can properly trace what queries are generated, what tables are being used, or what's the organizational background truth that's being leveraged at the customer lifetime value in this case. So I can then double check, ask for help in validation, or directly just try to tap into which are the results that I'm getting to validate everything's all right. As you can see, Collate is also giving, at the end, a nice summary of everything that it was able to discover. What are my customer values, different sizings of the segments, and the overall customer lifetime value distribution. In this case, I can see my average lifetime value by customer segment, how each of these segments is distributed based on a customer account, and finally, the total customer lifetime value contribution by each of these segments. Now, this is actually a chart that looks interesting enough that I would like to keep tabs on it and make it easy to share it with the rest of my team. Therefore, I'm going to pin it as a chart so that I can quickly go back to it without having to redo this conversation over again. In this dashboard, I can keep adding charts regardless of the conversation that they come. Then, as a team, we can keep building all of these curated pieces of information and insights that to have quick access, reference in the future, and refresh. Now, with Collate AI and the ability to pin and use these built-in dashboards, the time to insights gets easily reduced from weeks to minutes, removing the typical bottlenecks of data-driven organizations that always require everyone signing off before they can prioritize a random data analyst request. Now, I'd like to get some more eyes. This looks like a thread that we can pull further with the executive team. Therefore, I'm going to bring in Nick, our CFO, into the loop by sharing this chat.
Oh, it looks like a text from Parade, the RevOps team. I wonder what Parade has for me today. Let's take a look here. Oh, wow, this is a really interesting report. Looks like a customer lifetime value report. Be able to look at some insights here on our customer data. We've got our top 20 customer base by lifetime value in the segment. And I guess more importantly, look at this. I can actually verify that all this information is coming from a source that I trust. I love when these guys get me charts and information as the context that we're all familiar with. I can actually ask the system here to compute the top 20 retail customers by lifetime value that don't hold any of our lending products and show them in a graph. This way I could potentially identify some cross-selling opportunities. I'll be able to pass on this data to our sales team and make it an addition to some of our pipeline funnels. It's also amazing that RevOps gets me this information with a consistent background, consistent computational methodology. It allows me to feel comfortable moving forward with this from a pipeline perspective with our sales team. This is fantastic. Let's see what this visual turns out to be. All right, amazing. Now we've got this in graphical form. This will allow me to easily get into a conversation with our CRO. Now what I can do to make this even simpler is ask Collate to get me an automation in place so that I get this report sent to me weekly. It will show up every Sunday and allow me to broach the conversation with the CRO on Monday mornings. Now I don't need to be worried about reaching out, finding the data, double checking anything. It will all be in my inbox on a weekly basis. I can also, just to be sure, trigger this now so that I know that the email I receive is going to look and feel like I want it to. Let me take a look at the automation right now. Here I see it on Sundays. Hasn't been run yet, so this is a chance to run. This is my chance to run it right now to see the results. And here we are. The email I received from Collate, all the reporting information that we just went through in the system is also in this email. And most importantly, the chart is there as well so that I can be confident that all this information is exactly what I was looking at before.
Hi, I'm Mayur. I'm a data engineer at Costecki. The data teams here have already built up everything in Collate. That is the CLV definition, memory rules, and PII tags. Now, I want to take that context into Databricks where we run our production ETL. Let me show you how. I'm opening a new Databricks notebook. Databricks has its own AI agent called Genie Code. I'll choose that for creating a curated table. I have my Kostecki catalog, which contains a bunch of raw tables, and I want to create a curated table to help me find the customer lifetime value. And I want to build it with the right definition and the right governance automatically. I've already configured the Collate MCP with Genie so that it can pull context from Collate directly. Now, let me write the prompt to create the curated table. I've already allowed the MCP tool calls, and we can see that Genie is pulling definitions, metrics, and glossary term, everything related to customer lifetime value. It found the canonical CLV definition. It found the memory rule that says installment fees should not be included in revenue calculation, and it identified the PII columns that have been tagged in Collate. 3 different primitives flowing into Databricks agent through MCP. No re-implementation, no copying, just consumption. Now, let me just give it a prompt to create a PySpark script from it. Genie compiles all the information fetched from Collate, and here's the output. A production-ready PySpark code for our curated CLV table. Same definition, same memory tools, same PII tags, the governance team setup, and I never had to redefine any of it. That's what build context once, use it everywhere actually means with the open context layer from Collate.
Mayur has shown us how we can connect Databricks to Collate and OpenMetadata via MCP. Let's see other ways now that we can extract and use Collate context and semantics. Building AI applications can really help your teams automate tedious processes. With all the available options from commercial model providers or open source models, the LLM itself stopped being the hard part to tackle. And instead, that became giving that model the right context and semantics about your data and organization. What your tables mean, how your metrics are actually defined, which data is trusted, who owns it, etc., etc., etc. That context already lives in Collate, and it's constantly refreshed and updated thanks to the fleet of metadata agents scanning your sources. The only question here is, how do you get it out of Collate and into wherever you actually want to work? That's what the SDK is for. The AI SDK lets you interact with the Collate AI via Python, TypeScript, or Java, and provides both a CLI and an NNA node. You can then use the SDK to quickly build custom agents, for example, via LangChain, and back them with MCP tools to bring that super needed context and semantics. Or you can build AI-ready applications by directly interacting with Collate AI agents. Let's see how this looks. In this case, we have a simple notebook, but this could be a data application, Slack bot, a CI job, anything that runs Python. In just a few lines, we are pointing the client to our Collate instance, asking a real analyst question, how do I compute the customer lifetime value? And we stream the answer back token by token. As you can see, this answer is exactly the same that it's rooted in the foundation of our organization's semantics. This means that we can actually take all of this information and hook it up in any other application, in any other model, to make sure that all of the hard work that you are putting into Collate can be used absolutely anywhere else.
Before I jump into demo, I want to step back, connect this to everything we have been talking about today. We're seeing incredible innovation across Collate and OpenMetadata. OpenMetadata is the contact center for the enterprise. AI Studio and the AI SDK are making it easier to build agents, AI-powered applications. Now with MCP, every service, database, and business system can become callable by an AI agent. These are extremely powerful, and organizations are building their own AI agents using Collate as the contact center. But it also creates a new challenge. Customers are no longer just asking, can I build AI? They're asking, can I safely scale AI? They want to know which agents exist, which models are being used, which MCP services are exposing sensitive data, which application affects customers, employees, business relations. And if an auditor asks for evidence, can we produce it without a month of spreadsheet work? So this is exactly the reasons we built the AI governance module. What you're seeing here is AI Governance Studio. Instead of treating governance as a separate process, a separate GRC process, we're bringing it directly into the metadata and the context layer. The dashboard gives customers a live view of their AI estates, agents, MCP servers, LLM models that are being used within the organization. In this example, Collate has discovered around 19 AI assets. Some are pending review, some are high risk, and importantly, some are shadow AI, things that organization did not formally register, but Collate detected from metadata signals such as outbound API traffic, logs, and SaaS activity. This is the first big value, inventory and visibility. Most companies cannot give govern AI because they cannot even answer the first question, what AI do we have? Collate answered that by making agents, applications, LLM models, MCP servers, and all of this as a first-class governed assets. Once we have the inventory, the next question is risk. Here, Collate classifies AI assets by risk category. Is the risk is minimal, limited, high risk, or unacceptable? The dashboard also maps against the frameworks like UAI Act, NIST ARMF, IS, IEC 42001. The key point is that this is not a static checklist. It is grounded in open metadata context. What data the AI uses, whether it touches PII, whether it's deployed, who owns it, what downstream system it affects, whether it has the right monitoring and evidence. So governance becomes a data-driven. For example, if an AI agent reads a sensitive data, writes an action back to Salesforce, that is very different from an internal summarization tool. Collate can use metadata context to help customers classify risk and prioritize what needs attention. Now, let's go into the history of all the AI assets that we have. This is where concept becomes very powerful. We are not just cataloging tables, dashboards, pipelines anymore. We are cataloging the new AI operating layer, applications, LLM deployments, MCP servers, and agents. Here I can filter by type of applications, models, MCP servers, or agents. I can filter by risk and region, framework, or compliance state. This matters for customers because AI is no longer a single centralized platform. It is spreading across the teams. Marketing may use a Slack bot, sales may build a forecast agent, and platform teams may expose Snowflake through MCP. HR may test a candidate ranking model. Right? Without a central context layer, governance teams are blind. With Collate, they get one place to see and govern the entire AI estate. Now, let's say a team wants to register a new AI asset. The intake wizards walk them through the key questions such as, what are you building? Is it an application, an LLM model? Is it a chatbot? Is it a code generator? Who owns it? What data is being deployed? What part of the process deployment stage it is in? Does it touch any PI data? Which region does it operate in? The Collate suggests a risk classification. This is what will make governance easier for builders. Instead of sending teams to a long policy document, Collate guides them through the right questions in the product. It can suggest something is high risk because it touches employment data, customer eligibility, financial data, sensitive personal data. And then when they submit it, it goes to Risk Council for review. Production deployments can be blocked until the right controls are in place. So governance is not an after-fact audit. It becomes part of AI development lifecycle. And each of these assets in AI has a full understanding of compliant policies. We can see the owner, team, deployment, affected users, regions, compliance status. And the compliance tab clearly shows UAI assessment, risk classifications, up to 5 prohibited practice checks, and so on. This is where our context layer becomes critical. The system can explain why this asset is a high risk. It reads customer profile data, supports transcripts, and payment history. It connects to Snowflake, Salesforce, and Zendesk. Outputs can influence customer retention outreach. The context is what turns governance from a manual questioning into evidence-backed assessment. Finally, governance has to be continuous. In policies and drift, Collate monitors the estate for policy breaches. PII without a DPA, model drift about threshold missing, fairness testing, missing human oversight, or insufficient audit documentation. When something breaks policy, Collate opens a breach and links it back to the asset and remediation. Ask Collate can help governance teams move faster. It can summarize what needs to be attention, draft fairness evidence, trash, shadow AI, or prepare an audit pack grounded in the metadata context. And in audit reports, Collate turns all of this evidence back into UAI Act, NSD, ARMF, and other frameworks. And as a user, you can download PDFs or JSON for systems. And we also offer out-of-the-box different framework libraries that you can enable so that your AI estate can generate an audit pack for that particular framework. You can still innovate quickly and still build agents, applications, and MCP integrations. But now you can do it with visibility, ownership, risk classifications, continuous controls, audit-ready evidence. This is what makes Collate and OpenMetadata so powerful as the context center for the enterprise AI. The future of AI is not just about building more agents. It is about knowing which agents exist, what context they use, what action they can use, whether the business can trust them. This is the role Collate plays, the governance and context layer for enterprise AI.
All right. Hello again. Welcome back, everybody. Hope you enjoyed that product demo and deep dive in the last session. Just as a reminder, we do have 2 tracks that are running in parallel right now. You're in track 1, and we'll have Dan join on stage here shortly. If you'd like to see a session on OpenMetadata and the journey that Rakuten has been taking around unifying their assets and enabling discovery, you can click over on track 2. Again, it's on the stages icon on the left-hand side of your screen. Just click on track 2 and it can take you into that session. All right, so I'm really excited to bring Dan Kostecki back up on stage. He is a data engineering operations group he is in the data engineering operations group at Ambry Genetics, doing a lot of great things around data, as we described before, which includes ingestion mechanisms, transformation processes, multimodal clinical data within their data warehouse and application suite. And he has a background in biotechnology and chemical engineering and works to improve enterprise clinical data management and interpretation across a variety of Ambry Genetics and Tempest business units. Dan will be discussing clinical data products and data governance, which he alluded to in the governance panel we had earlier. And he has over 30 years of hereditary cancer data, 2 clinical organizations, 1 governance platform, and over 15 minutes to talk about all of that. So please welcome Dan Kostecki back to the stage. Hey, Dan, great to see you again.
Hey, thank you so much, Steve. Really appreciate the intro. So yeah, I'm Dan Kostecki. I'm a data engineer at Ambry Genetics, now part of Tempest AI. And over the next few minutes, I'd like to go over our approach to clinical data products and data governance. So just as a quick sort of overview and highlight, I'd like to describe sort of the problem stage for some of the issues and challenges we find with clinical data management and case management in 2026, and how the clinical data product concept is really changing and significantly improving the way that we store said case data. You'll hear a little bit about the clinical data product lifecycle, sort of the 6 main stages of any registered and novel data product from inception to completion. A few words about data governance with respect to quality and regulatory compliance. And finally, at the end, I'd like to show you a little bit about our first real production data use case for Collate, what we call our PHI-free lower environment. So let's jump right into it. So first, to set the stage with respect to clinical data storage, the take-home point is that patient information is not always static. What we call a case at Ambry is almost always a collection of biological and non-biological data, sort of a composite representation of both variant and biological information, and also order level attributes or non-biological commercial data that sort of makes up this concept of a case. So on the left is just a few bullet points about some of the elements, the biological elements that can change over time with respect to genetic variants and biological data in a patient case. So variants are constantly changing. They're being reevaluated. There's constant new streams of evidence and clinical research and academic research that goes into variant interpretation and clinical interpretation. Gene-disease relationships are also frequently changing, being improved, optimized, again, with associated evidence. And it's also worth mentioning that underlying clinical reference information can also change. So NCBI reference builds, for example, or specialized third-party databases like ClinVar, HGMD, MGI, OMIM, et cetera, in addition to changing clinical software, variant detection algorithms, sequencing methodology, lab instrumentation, and associated software, all of these can change over time. And that's just for biological case attributes. And on the right, just to sort of emphasize this even more, commercial or ordering information about a particular case can also change. Physicians can change in the original ordering organization. There can be changes to patient billing or reimbursement information. So the question we find frequently asking ourselves is, how do we most effectively manage these collections of biological and non-biological data that can and do change over time? And what we found is that the clinical data product concept is really changing everyone's lives for the better with respect to how clinical data is stored, transmitted, and managed. So as you've been hearing during the talks today, this concept of a data product is particularly germane to the clinical diagnostics industry. We found that, the combination of clinical and commercial case attributes within a versioned, coherent clinical data product provides several operational benefits. The data product operating model, establishing sort of the roles and governance from the get-go with the advantage of clinical data product storage is that the associated policies, user roles sort of set the groundwork for proper clinical data governance. If these roles are established from the beginning, it makes ingestion and creation of subsequent data products much easier if you have the roles and users defined ahead of time. The additional note about these roles and the invaluable contributions that each of the data stewards, data stakeholders, data product owners, all users and roles within the data product operating model are able to provide. And then at the bottom, the high-level domain map and source of truth that clinical data products, when created properly, provide is also invaluable. And we're finding that some of the built-in functions in Collate, especially lineage, quality, and classification, again, just make it a much more coherent data storage and accessibility sort of strategy. So to get into how we treat clinical data products, all novel clinical data products start with the definition and registration phases. On the right is just a hypothetical data product for a particular EGFR variant, hopefully not too difficult to understand. This is intended to be just a hypothetical request for 3 years of reclassification data for a particular variant. And you can see that sort of the form intake process is designed to be one line, super simple for any user to jot down their clinical data product idea, get it registered, and get it created as sort of the first step. Following registration and upon creation of the data product within Collate, now this registered data product is ready for subsequent metadata operations and quality checks. Not necessarily in that order, but those are the two next stages for all of our clinical data products. We find that it's essential to start thinking about the quality and lineage for anything involving clinical data immediately post-registration. So working with the appropriate data steward and data product owner, the idea is to take sort of these qualitative quality dimensions on the right and fit those to the particular data product that you've just registered. You can see that these are sort of, basis for data quality checks, again, with specificity and formalization coming with the interactions between the product requester and also the data product owner. It's just intended as a basis for what would the quality checks, how should they be defined for your novel data product idea? After data quality checks are established and assigned to the data product, that's when the built-in functions that are so invaluable in Collate start to be leveraged. Specifically, the profiler, lineage, and auto-classification metadata agents. we're finding it makes things much easier to perform these metadata operations for just about every new data product, lineage especially. It's invaluable for telling where exactly the underlying data for your data product was sourced from, when it was stored, what the data types are, if there are constraints, et cetera. Are there any extensibility issues? So these are sort of the two post-registration aspects that we like to emphasize for all new clinical data products and sort of formative clinical data products. So assuming quality and lineage functions are satisfied, this sort of moves to the post-registration and post-operability phase of clinical data products, really the maintenance and consumption phases. So after checking in and you have, your awesome data product, which is now visible, access restricted as necessary, quality and lineage are both accessible within the Collate platform, how do you maintain and who do you determine the appropriate target audience of your new data product? This figure on the right is just from internal presentation that I particularly like because it sort of shows how a particular like AI or ML pipeline derived data product is thought about with respect to like the domain assignments, also the consumption archetypes, and on the far right, the use cases for a particular data product out of many kind of described in the data platform column. So also worth emphasizing that consumption of novel data products that are considered cross-domain need to be visible, accessible, and emphasis on classification if your data product's going to be shared between various business units, and also if it's not considered for sort of 100% internal use only. And finally, a note about clinical data governance. Following the creation and sort of registration phases of your novel data product after that's complete, it's worth emphasizing, as you heard about in the panel, the regulatory and sort of statutes that all clinical data must adhere to. So within Collate, again, we're finding it very easy to incorporate quality checks, regulatory adherence, which all improves like the integrity, traceability, and accuracy of every novel data product that we create. The first bullet point and subpoints are just some of the regulations that our clinical diagnostics business is subject to. Again, as during the panel, there are a host of these. We're subject to local CAP and CLIA laboratory accreditation standards. PHI and HIPAA compliance is huge and also a major motivation for essential clinical data governance. FDA regulations with respect to electronic health records and storage also must be considered. And kind of similar to the quality slide, this FAIR acronym is just intended as a basis for regulatory adherence and also storage mechanisms. So it's intended to be sort of a, easy acronym to review when considering the regulatory and compliance portion of your clinical data products. Findability, sort of satisfied by extension following successful intake and registration of the data product. Evidence of data steward assignments, has a unique ID been assigned, et cetera. What data domains and classifications are relevant or applicable to your data product. Accessibility, most of the time this is role-based access controls, again, depending on the nature of the data product and if the intent is internal use only or research use or collaborative, that can change, but sort of the lowest common denominator is role-based access for every clinical data product. Interoperability is also always a question that should be answered as part of the regulatory considerations. Source to target definitions, differences in technologies and intended consumers of your data product, like AWS versus GCP, for example, differences in database technology or bioinformatics technology, et cetera. And finally, reusability. And this kind of emphasizes like the concept of modularity for every data product. After it's created and sort of passing quality checks, and it's a standalone data product, naturally, the intent might be to come back to it and then rerun the queries or associated components of the original data product. So reusability, auditability, and traceability kind of fit into that reusable bullet point at the end. And this is a decent segue into our first practical use case after we started using OpenMetadata and Collate with production environment, or with production data, excuse me. This was a request that was honestly a long time coming prior to adding Collate to Ambry's application suite. It's what we call internally a PHI-free environment. So just for context and for regulatory considerations, I'm sure everyone's aware how protected and how sensitive PHI-containing data is. And there's no exception for clinical data at Ambry and at Tempus. When sharing clinical data, PHI is handled with the utmost care. And it's been a long sort of request from clinical data involved business units to have a completely separate standalone environment that simply expunges PHI. There's no patient level identifiers present. It's simply de-identified, anonymized patient data from production that can be used for research purposes or for internal metrics or further analysis. So using Collate, we were able to define this PHI environment, which involved metadata ingestion for 6 PHI-free MySQL DBs, a little bit over 11,000 total data assets. And then through Collate automations, specifically like the tag and lineage functions, and again, with help from like our compliance and legal departments in defining the tags and classification categories, we're able to now keep track of all identified PHI data elements, do reconciliations between, the quote unquote real production databases and the PHI-free comparable databases, which, as you might imagine, like improves data quality checks, data fidelity between the PHI-free and normal production environments. So yeah, we're finding that this is pretty well received. It's saving people time. It's very easy to go into the PHI-free environment, quickly look up variant level information that, to a certainty is expunged of patient data or PHI and pretty much ready for dissemination. So we're pretty proud of that use case, and especially how the PHI-free lower environment turned out with Collate's help. And that was a quick overview of our approach to clinical data management and just some take-home points I wanted to share with everyone. Unifying mutable case data is difficult for the aforementioned reasons. It's difficult to keep track of changing clinical data and commercial data in the same case over time. We're finding that the clinical data product concept is a significant improvement to our approach to clinical data management, and especially the sharing, storage, and safe transmission of all clinical data. Another shout out and emphasis to the clinical data governance aspects, establishing a clinical data governing body, and especially unifying the Ambry and Tempus data governance approaches is ongoing and cannot be overstated how essential it is to proper functioning and storage of clinical data. And yeah, and the take-home point number 4, successful adoption and integration is evidenced by the PHI-free environment that we were able to create with Collate and OpenMetadata. So thank you all so much for your time. Really appreciate you letting me talk about clinical data governance for a little bit, and appreciate it. Thanks to Steve and Collate.
That was awesome. Thanks, Dan. Such a naturally great presenter, and it was great detail. We did get a comment or a question, but we're running just a minute over, so I'll follow up with you to answer that question for this person on the call. So thanks again, and we'll talk soon. Thanks, Dan.
Yeah.
Awesome. So yeah, that was awesome. And just as a reminder, we do have the 2 tracks. I won't walk you through it all, but if you'd like to see Serene talk about compliance and governance from a large financial services organization, you can click over in track 2. But we'll be here in track 1, and I'm really delighted to bring Jeppe Johansen, if I'm pronouncing that right. Hopefully he will correct me here, but really excited for him. Hey, I got a thumbs up to talk about that. So in this session, we're talking about the data platform team at Unity building Huron, a stream and batch processing platform built on Apache Flink and Apache Pymon. I hadn't heard of Pymon. Flink I've heard about before. So I'm really looking forward to your talk, and nice to meet you. So without further ado, I'm going to turn things over to you, Jeppe.
Thank you so much, Steve. Yeah, no, Payment is in an open table format. Go look it up. It's quite cool. It's built for real-time streaming pipelines. So as Steve said, I'm Jeppe Johansen. I lead the data platform team at Unity, and we built the platform that every single ads product runs on. And as Steve said and alluded to, it's built on Apache Flink and Apache Payment. And today I want to show you how we use Collate MCP to power 2 high-stakes workflows. The first is a compliance review, which we have already shipped. And the second one is incident triage, which we are building next. And both of them, they run through DAX, which is our team's Slack bot. At Unity, a lot of things happen via Slack, and this felt like a natural interface. And here's the thesis just up front. When you treat your catalog as infrastructure instead of documentation, the Collate MCP really is the unlock that makes that real. So just a quick scene set. As Steve said, I'm a senior manager at Unity, and my team is 8 engineers working on data platform across 3 time zones. And we own the platform that every single ads data product runs on. And the scale really, really matters here because it's the surface area that we have to keep accurate and compliant. So we have 23 billion ad impressions a month, and 165 million people see a Unity ad every single day. We have 2.5 billion players in games made with Unity, or rather that contains Unity ads, and 235 million app installs a month. And that's really what's behind the platform. So now let me show you the demo. So here's the whole thing in a screenshot. And sorry about all of the masked field names and such. Legal required it. But someone opens up Slack and pastes a request. And the request is, please review the L1 pipeline for compliance and quality. So a quick translation here, L1 is our enriched compliance check data layer. It's the data layer that consumers really rely on. So this review gate, or this review is really the gate in front of money and personal data. And DAX answers not with a link and not with a, I'll get back to you, but with a verdict right there and then. The schema is checked, PII tagging is checked, glossary coverage is checked, descriptions on columns are checked, and all of it is pulled live from our data catalog through the Collate MCP and then posted directly back into the same thread. And I'm not going to explain how it works just yet, but I just want you to sit with with what that experience is. You ask for a compliance review in Slack, and then a few minutes later, you simply have one. So this is DAX, and DAX is our data platform teammate, and DAX is a Slack bot, and it's using or leveraging a skill-based architecture. It's a bit more than that. It's not just skills. It's more like a workflow composed of skills and eval gates between each skill. But each skill is a self-contained capability, a prompt, a set of tools, and a job to do. And right now we have 12 skills, and every single cycle we ship more. And today I'm only going to talk about 2 of them: the compliance review, which you already saw, and then the incident triage, which is the next one that we are building. So first I'll zoom into the delivered skill and tell you a bit about what it actually does, and then I'll show you where the same pattern goes from here. So what DAX just did, let's unpack what happened in that one round trip. DAX fetched 3 classes of facts from the catalog live and turned them into a verdict. First, it fetched schema rules. DAX pulled the table schema through the Collate MCP and checked it against our conventions, naming, types, required fields, and the one with teeth, PII tagging. Every single column that carries personal data has to be tagged as such, and DAX checks every single one. Second, the glossary cross-reference. DAX asks the catalog which business glossary terms are mapped to this table and its columns. And if a column is carrying revenue data, for example, and it isn't mapped to a revenue term, that's a gap and it gets reported. And third, description quality. Every single table and column description gets graded. Not just does one exist, but is it actually useful? A description that says like the ID column, it doesn't get a pass and it's flagged. And then the verdict gets posted right back into the Slack thread. No UI hub, no dashboard, no ticket. And the part that I want you to notice here is that DAX owns none of this data. The catalog does. DAX just calls the catalog, and that's the whole architecture. So why did we build this? That's because the stakes are real and the old process really didn't scale. The stakes first. So a missed compliance review on ads data isn't a paperwork problem. It's billing accuracy problems. It's like a PII tagging problems. Those are 2 things that you really cannot get wrong at this scale. And since we are 8 engineers across 3 time zones, we cannot catch every single gap by hand. And the old process was a one-on-one DM or a 10-comment PR thread. The math doesn't really work, and the bottleneck is kind of the reviewer of the week, one engineer in one time zone, and the async drag is brutal. Like a review thread spanning Copenhagen and Montreal and San Francisco takes days just on like the time zone round trips, and the mandate is really only growing. 100% of Unity Ads data products producers, they have to route through data platform by the end of year. So the review load only really goes up. And the answer was not really, well, it never really was more reviewers. The answer was like move the gate to where the work lives. And for us at Unity, that's Slack, and DAX is how we did that. So the bet underneath all of this is that documentation lives in a UI and infrastructure lives behind an API. And for years, our catalog was something that infrastructure people read, and well, they were supposed to read it. And the Collate MCP kind of turned it into something that a bot can call, a glossary, schema, lineage. All of it became queryable at the exact moment a decision gets made, at the moment of truth. And the reframe is actually, that's the actual unlock. Everything else in this talk is just downstream of that one idea, really. So the results, like billing, accuracy, and PII compliance protected at the gate. All pipelines reviewed, like on demand from Slack, every L1 pipeline producer across every single time zone. A high amount of reviews now surface at least one or more issues, like schema gaps, PII tagging gaps, and glossary misalignment between different tables, weak descriptions. And it's not really a sign that our engineers are sloppy by any mean. It's more a sign that like the gate is catching what humans kind of have a tendency to just skim past. And the time to verdict, which is about 7 minutes now, like the reviewer of the week rotation is gone, and all of these multi-day PR back and forth, they are also gone. You ask in a thread, and then you get a verdict in the same thread 7 minutes after. And one of the examples that really stuck with me was that like a team was shipping a pipeline to L1, and one of the columns carried a user identifier that hadn't been tagged as PII. A human reviewer, like skimming 40 columns, would likely have missed it, but DAX flags it in the review, and the producer then goes and fixes the tagging before the pipeline is shipped, and the data is landed in L1 compliant on day 1. And that's exactly what the gate is doing, and it's exactly what the gate is there for. So same DAX, but new skill. Like the scenario here, like a data pipeline incident gets opened. Right now, the first 20 minutes, 25 minutes of that incident just goes to archaeology. What feeds this table, who consumes it, where's the pipeline definition. You're grabbing configs, you're like pinging people across time zones while the clock just runs and the company is losing money because we're not showing ads. So the next skill works like this. When an incident channel is open, DAX joins it and posts 3 things. Like the upstream the upstream producers feeding the affected table, and the downstream consumers that are about to feel it, and direct links to the payment table and to the pipeline definition, and all of the important things that you need to know in an incident scenario. Like all of a sudden, blast radius kind of becomes a query and not a search through documents and repos. And that's the line. And I'll be honest about what makes it possible. And it's like lineage coverage, it has to be real. And this works because every new data product going through the data platform has full lineage in the catalog. Like that, this wasn't a side benefit that we kind of locked into. Like it was the prerequisite for all of the things that we built. And notice what's also happening architecturally now. Like it's the same MCP, it's the same catalog, but it's a different question. Like the compliance skill asks the catalog, can this ship? And the triage skill basically just says, or answers the question, like how bad is it? And it's one source of truth answering both of the like highest stake questions that we have and that we have to answer as a data platform. So where does this go next? Like I won't read this grid for you, but I'll look at the columns instead. Like the now column is catalog backed skills running in production today. And next is what we're actively building, including the incident triage that I just explained. And later is the queue, a compliance gate that runs automatically on pull requests, where the teams actually define their pipelines, and guided producer onboarding, access reviews, and even deprecation driven from directly from the catalog. And the point of this slide isn't any of the individual cells, it's the pattern. Once your metadata is callable, every catalog shape question can just become a DAX skill or a question that you can answer through this. And compliance and incidents, they are just the first two that we tackled, and each new skill compounds on the same catalog. And that's really the investment thesis. So catalog as infrastructure is a claim, and the proof is what we now route through it, and it's compliance verdicts, incident blast radius, next PR gates, onboarding, and deprecation. So treat your catalog as infrastructure and route all of the consequential decisions through it. It really is quite nice.
That was fascinating, Jeppe. Thank you so much. I'm just curious, in those incident issues that you see come up with DAX now, you talked about some of the automation and just being able to pull information as needed through the APIs or MCP. What does that mean from a timing perspective? If something hits at 2 a.m., how much time is saved? Do people not have to respond as quickly, or how does that work?
So what actually is the biggest value add here is not the time that we get to not spend looking up things we already know. It's getting the data in the hands of the people that don't necessarily know where to look and are not used to handling cases or incidents such as this. And for them and for those scenarios, it's really gold. It's the ability or the benefit of just having all of this information downstream consumers, not just direct consumers of a given table, but all the way down into consumer facing products. It's really something, and having that readily available whenever an incident is open for a pipeline, it just really is something that you can only really dream about. I cannot express how valuable it actually is, because in a big company with thousands of data pipelines, blast radius is so hard, and it's so hard to pin down who to talk to, who to reach out to, and
I love the automation through your Slack bot. And DAX is a cool name. So thanks for walking us through that, and thanks for joining and sharing your energy and what you built with the rest of the community. Really appreciate it, Jeppe.
Of course. Thank you.
All right. Have a good night. Thank you.
Our next speaker is joining us from Tokyo with a story I think a lot of you will recognize: the challenge of bringing one metadata layer of shared understanding across a large global enterprise. Mukhtafi Ahmed is an assistant manager of the data pipeline platform team, the data platform department at Rakuten Group, a Tokyo-based company many of you know for e-commerce, whose e-commerce spans more than 70 business units across mobile, payments, media, and finance in over 30 countries. If you've been trying to consolidate a patchwork of catalogs, make discovery work across business lines, or stand up a context layer for your AI roadmap, Ahmed will share a bit more of Rakuten's story. Please welcome Mukhtafi Ahmed.
First of all, thank you for the introduction. So my name is Mukhtafi Ahmed from Rakuten Group. So here I'll be talking about our initiative to introduce open metadata into the company, with title Open Metadata Journey at Rakuten, Unifying Assets, Enabling Discovery. So this is the agenda of the talk. So first, we'll introduce the Rakuten business, and after that, the problem that we have, and how open metadata come as a solution and fit into the ecosystem, and lastly, about the progress and the future roadmap. First, introduction about Rakuten Group. So Rakuten Group was started as an e-commerce business in Japan in 1997. And then ever since then, we've been developing more and more services and then spread it over 30 countries and regions worldwide. So we have this concept of an ecosystem. So these various services and different services, they have this synergy between them so that we can generate more and more values to our customers. So some of the well-known services, such as Rakuten Rewards, formerly known as Ebates, and then the ebook reader, Rakuten Kobo, and then the video streaming, Rakuten Viki, and also the messaging app, Rakuten Fiber. And in total, we have more than 70 services and more than 2.1 billion users and global gross transaction value of more than 48 trillion yen. Now comes the problem statement. So in Rakuten, we have various data platforms, which is maintained by its own respective teams. And each team have their own solution and definition of what is a data catalog. So some team, they have some spreadsheet or Excel file. Some team have their like a Confluence page, and another one, they even build their own dedicated web app as a data catalog. And that's why we have this unclear governance, because each team have their own way of doing stuff. And then from the user's perspective, also it's unclear the relationship between data from one data platform to the another. And so there is no standard classification, taxonomy, and also domain. And this results in the unhappy data customers, which is mainly our data scientists and data analysts. So when they have their own problem that they want to solve, so they need some data, but don't know how to find it. And even though they found some data which might be useful, but they still having some problem to understand whether it's really useful or not. And then this one also result in the low data utilization in Rakuten. And the next, why open metadata? So we have at least these 4 reasons. The first one is open metadata offers technical metadata, business metadata, quality, and also observability that we are looking for. And the second one is that it's easy to use, the search and discovery features. And then also it also have the standard governance features which fit well with our use cases, with the notion of domain, products, tags, and etc. And lastly, it's an open source platform with a growing community. So based on these reasons, we see that open metadata is a complete package solution for Rakuten. So from the previous state in which we don't have any catalog solution, with the open metadata, so we expect that we will have a single consolidated catalog solution here, in which we can define a single governance standard and also provide the data search and discovery features, which make our users easy to find the relevant data that they need for their problems. And also, lastly, improve the data utilization. In addition to that, we're also expecting some drive cross-business growth. And also, we want to utilize also the AI features, which is offered by open metadata. So we have some examples here. So 2 of the businesses that we have in Rakuten. So business 1, they have 3,300 tables, and the utilization is about 60%. And we have business 2 that have 220 tables, which about 1/3 of the data utilization. And then from the user survey, we also found out that typically users need 2 until 3 months of time to find the useful data. So yeah, it's really time consuming. So this problem of low data utilization is making our data to have like low business impact. So because they are a bit hard to discover. And also because at the back, we already spent some money to compute and also to store this data, but they cannot maximize or utilize the data. So that's why there was also another problem, which is the maintenance load or the cost. And now it comes the open metadata as a solution. So we position open metadata here as a place in which we capture any data and process related to those movement. So starting from the operational data, which is typically the OLTP databases such as MySQL, Cassandra, Postgres, and also the NoSQL ones like MongoDB and Kafka. And then into the process itself, typically the data pipelines developed using Spark or Airflow. which after that, those data will be loaded into the data platforms that can be on the cloud or on the on-premise infrastructure. To access those data, we provide the Rakuten-wide data federation platform. And this is typically the journey of our data users. So first, when they have some problem which they need to answer using data, then they will first collect the information and list down which tables that can be useful for their problem. So they will find it from the OpenMetadata. So from which they can find or maybe filter based on the data product or the domain or the tagging and etc. And after they find out or list down the data that they can utilize, then they will visit the data federation platform from which they can query the data which is coming from the cloud or from the on-premise infrastructure. And the last section about the progress and the feature roadmap. So our journey with OpenMetadata started from October 2025. At the time, we list down the requirements, and then we look into some possible data catalogs which is out there in the market. And then after that, we compare those, and then we come up with the OpenMetadata as the solution that we select. We also do some POC to validate whether metadata really fulfill our use cases. And after that, we have our own first iteration production release. So at least those two businesses or two data platform that was presented before, we will onboard them into OpenMetadata and make it available to our data users. And after that, starting from July, we plan to stabilize the support and also the production operation. And also we will plan to onboard more and more data platform and business. And by doing so, we expect to improve the data utilization from 30 to 60% into 80%. And not only that, we also expect it will be getting easier for our data users to find the relevant data to answer the data problem. So previously we have 2 to 3 months, and then we expect it to be reduced to be less than an hour. And then lastly, about the features that we are using and also for the feature roadmap. Up until now, the feature that we use still the basic ones, such as the search and discovery features, and also the governance features using the data product, and also like glossary, tagging, and also the rules and policies to manage the metadata access and so on. And also we also testing some open lineage integration to make it smoother to integrate the data from various databases or process into OpenMetadata. And also we also playing with the Kubernetes native orchestrator, which enable us to deploy OpenMetadata without dedicated Airflow cluster, which is pretty cost saving. And for the future roadmap, we are mainly looking into these two features. So first of all, this the data observability. So for this data observability, mainly we are interested in the data quality and also data profiling, and also the lineage and etc. So that we can know better about the real time and runtime aspect of the data, so that it will help to with our pipeline operations. And the next one is the AI features. So we are looking at least into these two features. The first one is about the automatic description generation, because we have so many, like thousands and thousands of tables. So it will be very helpful for the data stewards if we can have to generate the description automatically, and then they will just check it and then make some small adjustments. And the second one is the MCP integration. So our main use case is, so assume we have some data engineers or data owner, which they found some problem with the data pipelines or or the data quality, and then they need to see which downstream data which is impacted, or how the lineage looks like, and then also they want to know the characteristic of the data. And then using this MCP integration, it will be easy for us to build some agent so that those agents can assist data engineers and data owners to debug and also smoothen their daily operations. And that's it for the presentation. Thank you again. Thank you for listening.
Ahmed, thanks so much for sharing the Rakuten story. It's definitely one I've heard from a lot of people in the open metadata community, people using spreadsheets and also these manual tools, and then trying to figure out a way to see across all these different sources of truth, because then you don't really have any sort of source of truth. But how do you manage that? I mean, you have all these different business units, you have all these different groups. Can you tell me a bit more about the different data teams that you work with and how you're going to try to roll out open metadata to them?
Yeah, sure. First of all, thank you for the question. So for these two businesses that I mentioned, so first, we try to learn about what is it that they have now, and then so we involve them from the start of the project. So try to list down what kind of problem that they have and what kind of feature that they are looking for, and then that's how we come to the selection to use the open metadata. And then we feel that because we already involved them from the start, so it's easier for them to accept, oh yeah, this is the solution, that is the answer to our problems. So I think that's the way we get the buy-in from the data platform or the businesses. Yeah.
Makes sense. And how are you looking to roll out open metadata to the different business groups?
So what we are doing is so we start from this the user from those two businesses or data platform. So so we do it incrementally. So first we start from those two, and then we broadcast the open metadata deployment that we already prepared, and then just let's see their the users reaction to that. And then if it's a success, then we plan to roll out to more and more businesses so that we can get a wider coverage and we can get more people to better use it and also get more feedback and keep the loop running.
All right. Ahmed, thanks so much for telling your story. I really appreciate it for us and behalf of the larger community.
Yeah, sure. Thank you.
Hello, everyone. Welcome to our track here for UnionBank in Philippines. I'm proud to present Serene Simon Simbahen as the head of data trust and governance at UnionBank of the Philippines, one of the country's largest and most digitally forward banks, and how they're here to tell the story about operating in one of the world's most regulated industries with open metadata and Collate. Over the past couple of years, Serene's been leading the work to overturn governance into a more observable and automated process with lineage, ownership, and quality context signals for both human and AI consumers to see and act upon. He's going to walk us through the journey, the lessons they've learned, and where they're going next. Please welcome Serene Simon Simbahen.
Hi everyone. So this is Sai. I'm the head for Data Trust and Governance Office at UnionBank. Thank you, James, for the introduction. So let me head straight to my presentation. And today, I'd like to share our journey from manual data governance toward observable data governance. Now, operating in banking makes this journey very different because in a highly regulated industry, data governance is not simply a documentation exercise. It impacts regulatory compliance, operational resilience, audit readiness, customer trust, and increasingly, the organization's readiness for analytics and AI-driven operations. As our enterprise data ecosystem continued to grow, we realized something important. Data governance existed, but data governance was not always operationally visible. As our data ecosystem expanded, maintaining visibility and consistency across the enterprise became significantly more difficult.
We had more pipelines, more reports, more dashboards, and more interconnected data flows across the organization. Many governance activities still depend on manual coordination, fragmented metadata visibility, and slow lineage investigations. But one challenge stood out the most for us. What we internally call the data historians. Uh, these were individuals who carried years of institutional knowledge in their heads. They knew where reports originated, which pipelines fed into which dashboards, which datasets the business trusted, and why certain transformations existed. And while that knowledge was valuable, it also created operational risk. Because once those individuals leave, transfer, or retire, suddenly nobody knows what. In a highly regulated banking environment, that dependency on tribal knowledge was simply not sustainable. So the question became, how do we make data governance operationally visible instead of dependent on people and spreadsheets? This challenge become even more visible as we look into our operational metrics and KPIs. About 11% of governance service desk requests were related to observability and discoverability concerns alone. Questions like, where did this report come from? Which upstream datasets changed? Who owns this data asset? Which dashboards are impacted? At the same time, we had over 40,000 production data assets across the enterprise and hundreds of dashboards consuming shared datasets and pipelines. And in some cases, tracing lineage or identifying root cause could take several days, not because people lacked capability, but because the ecosystem had already outgrown manual data governance approaches. And unlike smaller environments, banking ecosystems are deeply interconnected. One upstream issue can affect regulatory reporting, operational dashboards, analytics outputs, downstream business decisions, and even AI-driven use cases simultaneously, which means visibility and traceability are not just operational conveniences, they are control requirements. At the same time, UnionBank was also transitioning towards data product operating model. And this became a foundational shift for us because data products introduced something data governance critically needs: clear accountability. Instead of data existing in disconnected silos, data became organized around ownership, stewardship, reusability, and operational responsibility. But we also recognized something important. A data product operating model alone is not enough. Because if ownership is not visible, or if lineage is not traceable, or if trust signals are not measurable, then data governance still remains largely theoretical. So we started embedding governance capabilities directly into the operating model itself. Data product owners, data stewardship, data grading, lineage visibility, quality standards, usage context. Because data governance needed to become embedded into how data operates, not just how data is audited. This was really the turning point in our journey. We shifted our mindset from traditional data governance towards observable data governance. Traditionally, data governance was heavily documentation driven, like static policies, spreadsheet based monitoring, manual lineage tracking, and manual lineage tracing, reactive investigations, fragmented ownership visibility. But observable data governance changes the equation. Now, metadata becomes operational intelligence. Lineage becomes uh, searchable and traceable. Ownership becomes discoverable. Impact analysis becomes significantly faster, and governance visibility becomes embedded directly into operational workflows. In regulated industries like banking, this becomes especially important because governance teams are constantly being asked questions like, Where did this data originate? Who approved this transformation, or which reports are impacted? And these questions cannot reliably be answered through tribal knowledge or disconnected spreadsheets. Observable data governance allows governance to move from documentation towards operational intelligence. And perhaps most importantly, data governance stops becoming a gatekeeping function and starts becoming an enablement capability. As governance visibility matured, we also needed a consistent and operational way to communicate trust and intended usage across the enterprise. Because not all data carries the same level of trust or governance expectation. That led to our data grading framework. The data grading framework introduces 4 specifically crafted data grades, which is based on the medallion architecture, which basically introduces authoritative data for regulatory and critical reporting, validated data for business decision making, curated data for analytics and operational reporting, and exploratory data for discovery, sandboxing, and non-critical usage. So what made this powerful was not just the framework itself, but the fact that these trust signals became operationally visible through metadata. Now, our users, our internal business users, could immediately understand, can I trust this data set? Or what is its intended use? Or what governance expectations applies to it? And this significantly improved alignment between data usage and enterprise risk tolerance. As governance visibility became more integrated into operational workflows, we started seeing measurable improvements in our KPI. So we saw 90% decrease in requests related to data discovery and observability, a lot of time saved doing other stuff on our side. We achieved complete metadata and lineage visibility for dashboards consuming governed data products. Critical data assets achieved full data quality coverage, not just domain-driven, not just specific data assets, not just request-specific data asset, data quality coverage. And investigation timelines that previously took multiple days were reduced significantly for activities such as root cause analysis and remediation activities. Uh, Apparently, from 5 days up to 2 days, time saving around 3 days means a lot on a governance control unit like the data trust and governance unit. Now, to be clear, this journey is still evolving. And observable data governance is not a one-time implementation or not an overnight kind of thing. It is an operational maturity journey. But these early outcomes validated something very important for us. Data governance scales significantly better when visibility is embedded directly into the system. So I'd like to close my presentation and speaking engagement with you guys with a few lessons from our journey. So first, data governance must be observable. Policies and frameworks alone are not enough at enterprise scale. Second, metadata becomes significantly more valuable when treated as an operational intelligence layer rather than static siloed documentation. Third, data governance cannot depend on tribal knowledge, or at least not depend on it alone. One of the biggest operational risks we identified was overdependence on what we call data historians. Critical governance knowledge existed in individuals instead of systems. At enterprise scale, especially in banking, data governance knowledge must become centralized, searchable, traceable, operationally sustainable. Because governance continuity should survive organizational changes. And finally, data governance and technology must evolve together because scalable data governance is never achieved by governance teams alone. It requires engineering collaboration, operational enablement, metadata automation, and shared accountability across teams. And ultimately, observable data governance is not just about implementing tooling, it is about making trust operationally scalable, especially in banking where data governance needs to remain resilient regardless of platform complexity, organizational changes, personnel turnovers, or evolving analytics and AI initiatives, because data governance should not disappear when your data historians leave. Data governance should already be embedded directly into the ecosystem itself. That is what allows organizations to scale not only governance, but also trust, accountability, operational resilience, and long term innovation readiness. Thank you. Thank you, everyone. And thank you to Collate and the Collate Summit team for the opportunity to share UnionBank's journey in transitioning into an observable data governance.
Thanks so much for sharing your story, Serene. That's a lot of stuff to unpack, going through all the different layers of data trust, sort of the impacts to your business. We're actually at the end of time for our session today, but really thank you so much for sharing all those different insights and hope to hear more from you as you continue on with your journey on bringing observable governments to UnionBank of the Philippines. Thanks so much.
Right. Thank you, James. Thank you, everyone.
All right, so that was awesome. So I think we are converging tracks now. We should all be coming back together, tracks 1 and track 2. So of course, we're going to close things out with a poll question. So the last one, would love to have your participation on is if you could deploy one AI capability on top of your data this year, which would deliver the most value for you? Is it a self-service AI analytics so that anyone in the company can ask questions in natural language, which you saw Bonnie speak about? It was in track 2 as well in terms of what Collate AI enables. Is it more on the back end of your data operations in option B, where you can have agents that are doing documentation, tagging, classification, quality, that sort of a thing? Custom agents, do you want to build agents on top of this metadata and governed context? Do you want to do automation of governance and policy enforcement, or are you still trying to figure out what to do? So if you go over to your polls, I will try to do the same thing. Poll number 5. Where did it go? There it is. All right. I think for me, self-service analytics is something we've been talking about for a long time, and it's been a long time coming. 20 years ago, I worked at Business Objects. We had a project called Mistral, and it was all about natural language. How can we let someone essentially write in English and then query a report? And it didn't work great. And so I think we're in a very new time. So that seemed to be the number one response from other people. So about 47% of people said self-service analytics. So people can ask questions in natural language. At the end of the day, it's being able to get insight from your data. So that's a big one. And then custom agents. People want to build specific agents on top of their governed data. Also top, and it looks like automation is also moving up. So keep answering, and we'll share these back to everybody in the audience as well. So thank you very much. And so really excited for the next session. We're going to give an Open Metadata community update. So I will be bringing Sean Gordon up here in a minute to walk through that and give the update. And he'll have a special guest joining him, as I mentioned. And then I'll rejoin Sean, and we will hand out some awards to folks from the Open Metadata community and our Collate customers. So we'll be back soon. Sean, we're going to pass it over to you if you want to take it away for the Open Metadata community update.
Hi, I'm Sean Gordon, Senior Developer Advocate here at Collate, and we have been having an amazing summit so far. And now it's time to talk about the Open Metadata community and some of the stats and growth we've seen since our last event, and I've got a little bit of surprise as well. So let's jump into that. So here are the stats from our last event in October, where we had 11,000 community members, 2,000 enterprise deployments, 7,800 GitHub stars, 370 open source contributors, and 100 plus data connectors. Now, what has happened in the 8 months since then? We have increased community members by 23% with over 13,500, a 50% increase in enterprise deployments with over 3,000, an 80% increase on GitHub stars, over 14,000 now, a 22% increase in open source contributors, and you guys are the lifeblood, over 450, and a 30% increase in our connectors with over 130 now. Now, Steve, about that surprise I promised, last year's Open Metadata Developer of the Year Award winner, Eamon Dench. Welcome, Eamon. I'm glad you could join us.
Hello, Sean. Well, first of all, thanks again for having me.
Yeah, it's this is a great surprise for everyone, I think. And I want to get your perspective. Given your deep involvement in the community, I thought it'd be cool to get what you see or think about the best way to work with the community and get the most out of the community, be a productive, loved member of the community.
Totally. Well, first of all, I've actually had the chance to follow the evolution of the entire Open Metadata project almost from the beginning. I started working with it, I'd say, 4 years from now, and it's been really impressive to see the whole progress and how much this project has grown. We've seen, especially from the last year, we've seen a substantial jump, I would say, regarding the communities like members, all of the Open Metadata, I would say GitHub repo stars. So there's been a lot of progress recently, and I would say regarding the community, the best part for me is not only about the numbers, but seeing the community helping each other every day, asking questions, sharing feedback, contributing, trying to make Open Metadata better every day. That's what makes it truly unique for me. And especially, I would say it's rare to find like an open source project with this level of support and engagement.
That's good.
So, yeah.
So be an organic, helpful member of the community, be what it is you would like to get.
Totally, exactly, totally.
That's awesome. Maybe in 30 seconds, what do you envision over this next year?
Well, totally seeing Open Metadata continue to grow, both as a project and as a community. Well, we've seen recently a lot of progress regarding all of the AI features that have been implemented in Open Metadata, of semantic search, the ontology, the knowledge graphs, and all of that stuff. It's been really amazing. I would say let's just keep building. Let's just keep building open metadata. Let's just keep working together and making open metadata the best metadata and data governance platform out there.
Like it. I'm just thinking about everything I get to build, and you're going to get to do it too.
Let's go. It's all about the community.
Absolutely. All right. Thanks so much for stopping by, Eamon. I really appreciate it.
Thanks again, Sean, for having me. See you on the next side.
And that leads us to the other part of the story, and that is what people go and build with open metadata and Collate. And we had some awesome surprises this year, and that seems like a good spot to hand it over to you, Steve, to start us off with some customer awards.
Absolutely. This is the most exciting part of the whole event for me, so happy to. We've picked 5 customers this year. We had a lot of nominations internally. I've also had a lot of discussions with many of you and customers that spoke today at the conference. And there's really been 5 teams that have pushed the platform, and in a couple of cases did some things we hadn't even thought of before. So let's get right into it. First up, we've got the AI Innovator of the Year. This is the boldest thing that anyone's done in terms of building on top of a metadata foundation this year and really driving AI innovation. So drum roll, please. The AI Innovator of the Year goes to OpenAI. Their team, as you saw earlier, Bonnie spoke and talked about Kepler, which is letting anyone in their company ask a question in plain English and get a real answer back. And the scale is a little bit hard to wrap your head around. You think about tens of thousands of data sets, hundreds of petabytes being queried every day, and they've got thousands of internal employees at OpenAI that are using it. And what I found most interesting is that it learns and stores these learnings in memory, which is part of what you heard throughout the conference today. So that combined context, which brings together metadata, semantics, and memory, are improving accuracy, speed, and ultimately token usage. If you think about it, now, I don't know, OpenAI's bills may be a little bit easier to pay than some of ours, but that token usage can really add up if you've got an LLM that's going straight against the data set. So anyway, context matters. And that question that initially took 22 minutes, as Bonnie showed, in the first run is done in about a minute in the next, because that agent remembers what worked. And open metadata is the foundational layer that makes all of that context possible. So Bonnie and her team, thank you for showing everyone what this can look like. And many people are trying to put that into production. So let's go ahead and roll her video, which she accepted the award from.
Hi, I'm Bonnie Xu, and I'm the tech lead of the data productivity team at OpenAI. I'm really honored and grateful to be accepting this award on behalf of the team. We have an internal AI data agent that makes it possible for anyone at the company to get the data answers they need. Today, the agent helps more than 3,500 internal employees work across 70K data sets and reasons over 580 petabytes of data. At that scale, the hard part is not just about finding the right table or writing SQL. It's about getting the right context, knowing what data exists, what it means, and how it relates to the business. This is where open metadata has been so foundational. It is an important part of our 6-layer context model so that the agent can reason more like a real analyst. One thing that surprised me the most was how quickly the system could improve when we treated metadata and memory as first-class infrastructure. One optimization brought query time down from 22 minutes to 1 minute and 22 seconds. This was a concrete reminder that agentic systems can get meaningfully better when they learn from their environment. Looking forward, I'm excited for our data agent to become an even more capable partner for analysis, more proactive, more reliable, and more deeply connected to the knowledge that open metadata helps us maintain.
All right, that's a tough one to follow up on, Sean, but you're up next. What do you got for us?
Well, you're not kidding about that. Thanks, Steve. Our next award is for business impact, and it goes to a team that took a big idea and actually made it pay off. Here's that drum roll. And congratulations to Scout 20. If you're in Germany, you already know them. They are the home of real estate in that market. And a lot of people are talking about AI agents. Scout 24 wired it into how the business actually runs. They built what they call the AI virtuous cycle. And their AI pulls trusted context out of Collate to answer a question, and every answer it gives feeds new context right back in. The context layer keeps getting richer on its own, and the answers keep getting sharper over time. It is a similar approach to what OpenAI built internally with their own data age, which is an interesting company to be in. So keep in mind, this is a public company, so the bar for trust is very high. Their analysts and product owners rely on these answers to make with a confidence score telling them how much to lean. Okay. Angelita Frozza Sanchez put it well. Context is the product, AI is the multiplier. Congratulations, Angelita. Let's hear from Scout 24.
Hey everyone, I'm Angelita. I'm leading the data infrastructure and governance function here at Scout 24. I'm honored to accept this award in behalf of the Scout 24 and many engineers, data professionals, governance specialists, and business partners who made this possible. When we started this project, our goal was simple: create trusted context for both AI and people. Together, we transformed a traditional data catalog into a context catalog, a single source of truth that connects data, governance, and organizational knowledge. We also built an AI virtual circle where every interaction enriches knowledge and every enrichment improves our future decisions and AI experiences. This achievement isn't about technology alone, it's about people, it's collaboration, shared vision, and commitment to responsible innovation. Thanks Collate and thanks Scout 24 team. This award also belongs to the whole Scout 24 team that made this possible. Thank you.
Excellence, governance done right at serious scale in a highly regulated environment. Drum roll, please. This one goes to Ambry Genetics. As you heard in the panel discussion, and if you went to Dan's breakout, he's got an incredible environment that he's working through with the integration of Tempus and now Ambry Genetics, on top of the fact that they're dealing with personally identifiable, PHI and other types of data in their environment from the genetics. So if you want to see governance in high regulatory pressures, this is really one to look at. So they've got over 11,000 assets across this regulated multi-system clinical estate with automated PHI tagging and removal to stand up a safe PHI-free research environment, governed under a number of acronyms, including HIPAA, FDA 21, and with FAIR built in. And they're providing a clinical data product model unifying mutable genomic data in one source of truth. So to Dan Kostecki, Carl Allen, Mark Personet, and the whole Ambry Genetics / Tempus team, thank you for setting the bar this high and showing us how it's done. Let's go ahead and roll that video.
Hey, this is Dan Kostecki from Ambry Genetics, just saying thank you so much to the Collate team for the Data Governance Excellence Award. At Ambry, we're establishing a clinical data product operating model that's built on Collate and OpenMetadata, which is allowing us to consolidate complex clinical and genomic case data into governed, trusted clinical data products. These updates are allowing us to govern thousands of data assets, automating how we ingest and classify PHI elements per tested patient, and also provides the basis for a data stewardship program across Ambry. All of this occurring within a heavily regulated genetic testing environment. And pre-Collate data governance used to slow us down. And really now it's what's allowing our teams to safely share data and move much more quickly on research and diagnostic use cases. Thank you so much.
Really well done. Congrats again to the Ambry Genetics team. Sean, over to you.
Well, this one is a personal favorite because it's open source through and through. OpenMetadata in production for the team that took the project the furthest. Drum roll. And it goes to Yelp. Most of us build metadata tools for people to click around in, but Yelp looked at it differently. They asked, what if the user is an AI agent? So they built a custom MCP tuned for agents instead of a screen. And they cut the tokens a catalog search needs by about 2/3, from close to 800 down to under 300. That means faster, cheaper, and sharper agents. The best part is they gave it back. they contributed those search optimizations to the open metadata community, so everyone in this room benefits from the work they did. They proved that metadata is not a side tool, it's a core infrastructure. Amy, Forrest, and the Yelp data platform team, thank you. Let's take a look at what she had to say.
Last year, Yelp's AMS engineering team had an opportunity to select a better data catalog, ready for a world with a growing appetite for data. Our non-negotiable started at a great user experience for contributions and discovery. OpenMetadata was well suited for us because it was open source and extensible. With search being top of funnel, we enforced strong opinionation of the search, leveraging the flexibility of APIs to build a highly customized search algorithm. We also delivered persona-specific asset visibility, end-to-end lineage, and a token-efficient internal MCP. At launch, our focus lied on analysts, but engineers quickly became a priority as well. That meant building tooling around contributions enablement, certifications, and extending services covered with partner teams like Streamhouse and ML Compute. Internal feedback so far has been overwhelmingly positive, with our catalog quickly growing to become the backbone of agentic data use at Yelp. Our first priority was discovery, but now our focus shifts to building a platform for better data context.
Okay, Steve, you've got the last one, and it's a good story.
Yeah, absolutely. This is one of my favorite awards. So last but not least, we have the Design Partner of the Year award. And this is the customer who didn't just use the product, but they actually helped us build it. So drum roll, please. This one goes to Divisions Maintenance Group, or DMG. DMG had a problem a lot of you will recognize. They pointed an AI straight at their database, and they gave different answers to the same question, which kills trust quickly when you're trying to do analytics self-serve. And they had hundreds of users that they wanted to be able to give this AI interface to. But they knew they had rich context with Collate and asked if we could help them build a solution to replace the tool that they had originally tried to build this in. So together, they rolled up their sleeves together with us and built Collate AI Analytics with us as part of the 1.13 release on top of our semantic layer. And I can tell you, our teams were on calls together multiple times per day. So this was definitely a partnership that we worked on with them. And as such, they became our first customer of what is now called Collate AI Analytics. And they're the reason it shipped the way it did. They told us what mattered across spreadsheet uploads, split panel views, shared access, and many more. And it really landed well with the business. And not to steal their thunder, but when we see the video, they'll talk about how they had they have nearly 80% of their non-technical folks in the operations team that are now using this as their source of truth. So like Neil told us in the pre-brief and in the video, they got a better product faster than either of us could have developed or built alone. So to Sanjay Lohani, Neil Taylor, and Piyush Nahar, thank you for building this with us. And here's their take on that design partnership.
Thank you, Steve. We've been partners with Collate a couple of years now. We were one of the early customers, and Collate has our enterprise data governance layer. It also has our semantic layer. And in our initial attempts at LLM powered analytics, we pointed the LLMs to directly at our databases. And it turned out that the results were fairly inconsistent. You could ask the same question slightly differently, and you'd get a very, very different answer, even if the user itself made the same thing. And so we really work closely with Collate to say, look, you have our semantic layer. Collate has an understanding of our data. It is our sort of certified data store. Can we not build something like this together that will give us much more consistent results, even if you are a non-technical user? And so it's been a great partnership. We've been super happy with what we're seeing. It's widely used across the organization now. And as a technology leader, I don't worry anymore that we're going to be making the wrong decision based on data. So it's been a big boost to us. So huge thank you to Collate for letting us partner with them.
I really want to emphasize the partner in this relationship. From the very beginning, we started with building up our data governance, the glossary, not only of translating our database into terms that are consistent across the organization, but taking individual metrics and KPIs and things that go into building the reports that run the business. We were able to bring all of that into Collate. And it's a popular enough tool within the organization that we have. It's not just a technical tool anymore. We have a huge number of our product people and business folks who are contributing to building up that data governance data set with all the information about the semantic layer, all of the metadata, and all of those things that go into making the AI tool so effective for us. It's been a journey, and I think that our data team and the Collate team were on calls sometimes multiple times a day, working through how the data is going to be presented, what kind of guardrails are put in place, how can we help our users, which for us, our users are largely non-technical. So your product people, your sales marketing people, our go-to-market team, both the responsiveness, the interest in our success exhibited by the Collate team, and the quality of that interaction was second to none. I don't think that we would have, in the time frame that we had, I don't think we would have been able to deliver as good a product, either of us individually, than what that partnership delivered. So we have a continuing rise of people who are using the AI platform. And it just continues to grow. The people who use it continue to use it, find new uses for it, things that we never even thought of. And they tell two friends and they tell two friends, and all of a sudden we've got, nearly 80% of the operational side of the business on the platform. So it's been a great experience.
All right, so there you have it. 5 customers, 5 completely different ways of pushing what's possible on top of context to put trusted data and AI into production. So to OpenAI, Scouts24, Ambry Genetics, Yelp, and DMG, congratulations again. Thank you very much. I think some of you have gotten the last trophy already. Some of you, it should be coming in the mail shortly if you haven't already received it through customs. But you're really the reason we do this. And that's a wrap on the Collate Summit 2026 awards. Congratulations to all of our users.
Thanks everybody.
So as we wrap things up, let's bring the day back together. If you could please share my slides up on production there. 4 key takeaways I hope you carry out of here today. Congrats again to all the award winners. One is that context layer. You heard it a bunch of times. It's the difference maker for AI, not the model. And every story we heard today really came back to that semantics and memory and data context, really grounding the answers for bots, agents, and people to really make life easier. 2 is build context once and use it everywhere. So people and agents work from the same source of truth. Governance, of course, as number 3, is not a separate track. It's part of the ride, and making sure that you have trusted governed data and governed AI is what makes it safe to let agents automate more and more in your business. And 4, you don't have to be a frontier model lab to do this. That's exactly why Collate and the Open Metadata community exist. And so it's great that we're all sharing this information and knowledge with each other of how to do more. And that's a perfect note to thank this community before we look at what's next. So to close things out, we won't have time for any Q&A, but if you have any questions, drop them in chat. We have been chasing down folks to get answers, including OpenAI, who had to drop for another call. But thank you for all the participation this week. So there's a lot of information coming this week. We've dropped a lot of stuff in chats, and of course we can follow up with you. But I would encourage you to read the news that came out. We have a lot of new blogs and product pages that have gone live with more details and everything you heard from Harsha and the team around Collate 2.0. Thank you so much for joining us today. Hopefully you got a lot out of the session. We certainly enjoyed putting it together and looking forward to building the future of AI for data with each of you. Thank you very much and have a wonderful day.